Aloha, my kako. My name is Destiny Apilado, and today I will be presenting my capstone project titled Place-Based Equity for Hawaii's Local Producers. This work was done under the advisement and mentorship of Dr. Susan Crow, Dr. Travis Idle, Lala Nuss, and Dr. Jonathan Dienick. So to start us off, what is equity, or what is place-based equity? Equity itself means to have equal access to opportunities and outcomes. This is different from the idea of equality because instead of viewing all individuals as the same, equity recognizes how different individuals or vulnerable populations require different sets of resources to have access to the same outcomes and opportunities. And when considering how to apply equity within policies, there are 5 dimensions to consider, and they're related to how benefits are distributed, how institutions steward transparency and accountability, how future generations are considered, how multicultural norms are valued and recognized, and how decisions are collaboratively made. And when taking this idea of equity and making it place-based means to consider the local context of values, of challenges, and histories that are relevant to the most vulnerable population within a community. Going a little bit into the policy, within the USDA's recent trajectory, equity has been a priority through their work, especially due to class action lawsuits for discrimination against Black farmers, Hispanic farmers, and women farmers. In 2021, the USDA established the Equity Commission to advance racial equity and support for underserved communities by removing barriers to access and working to repair past mistakes that have resulted in economic, social, and racial disparities. Within the USDA's Farm Bill, they've defined the terms historically underserved farmers and ranchers, and this is to give underserved communities access to things like special provisions for set-asides, waivers, and advance payments. And this includes farmers who are limited resource, beginning, socially disadvantaged, and veteran. These terms were historically underserved that they define is developed based on national equity concerns. So when applying that to farmers and ranchers in Hawaii, it's important to realize how the lack of place-based knowledge in these policies can allow inequities to persist locally. And applying place-based equity within the policies related to how incentives, grants, and loans are distributed is important because it could have either positive or negative feedbacks on the intended outcomes, such as climate resilience and local food security. So if there is inaccurate place-based equity applied, we can see marginalized populations continue to be marginalized, and this can result in exacerbated institutional distrust and non-participation in USDA programs. On the other hand, if place-based equity is accurately applied by recognizing local values, challenges, and histories, we can see trust building between communities and institutions, resulting in increased participation in programs, and that will positively impact the actualization of the social ecological outcomes. So within my project, I've developed 2 objectives. First is to explore local equity contexts that affect Hawaii's producers from accessing resources such as grants, loans, and incentives. And I do this by applying place-based research ethics and conducting community outreach. My second objective is to develop and communicate policy recommendations and share that with key policymakers and decision makers. This is to effectively enhance or to encourage positive feedbacks onto those outcomes I mentioned in the last slide. And the stakeholders that I focus on is the Natural Resource Conservation Service in the Pacific Island area, Hawaii Climate Smart Commodities, which is a USDA funded group of partners within Hawaii that support farmers in climate resilience on their farms, and also with state legislators. To achieve these objectives, my priority was to incorporate place-based research ethics. So that's things such as the Kulana Noi'i and the PEVA framework. And these resources guided my design in my research project to rely on communities as knowledge holders and make myself their ally as a researcher. I also practice reciprocity through this project as outlined in the Kulana Noi'i that doesn't always take the form of monetary compensation. So I practice reciprocity by volunteering a lot of my time and investing a lot of effort into building meaningful long-term relationships with individuals within the producer community and those who are especially impacted by institutional distrust. Though this doesn't necessarily benefit those directly who participate in my project, but keeping that long-term focus on what my project really aims to do, which is to benefit our local community, was kind of the idea of why I chose that way of practicing reciprocity. Going into how I collected my data, I like to think of that more as collecting the community voices. So I conducted 20 talk story interviews with local producer supporting organizations and collected 72 survey responses from local farmers, ranchers, and mahi'ai. I took their community input, thematically analyzed it to identify barriers to accessing resources, and develop localized terms for underserved communities based on those barriers. In terms of the representation of my community input, most of the voices were coming from Honolulu County and Hawaii County. However, I was able to speak with an organization from each of the 6 main islands. So within Maui County, I have 3 organizations listed there, but that includes Maui Island, Lanai, and also Molokai. Now, going straight into the data, within my survey, I asked if the producer that was responding to the survey, if they can qualify as a historically underserved producer according to USDA's terms, and of which 83% of the respondents said that they do. There's 2 things that we could kind of infer from this. One, perhaps my sampling was biased in selecting for more underserved farmers, or 2, that these terms for historically underserved are not precise enough to be able to target those who are truly not being invested in by institutions. To kind of support that second inference and bring in some mana'o from an interview, I want to share something about the category of beginner. We can see most of the producers that qualify as historically underserved fall under that category. It was shared with me in an interview how within that category, somebody can come into Hawaii from out of state with capital that our local community doesn't have access to, giving them privileges if they're to qualify as beginner, but giving them privileges to resources that are meant for those who are truly underserved. And then so the question becomes, how should we identify underserved farmers here in Hawaii? Through my interview data, I found that there were 4 groups of farmers that were especially impacted by the barriers to accessing resources. And those groups include Native Hawaiians, immigrants, subsistence farmers, and also short-term land leasehold farmers. These individuals or these groups of producers face challenges with conflicting values, locally experienced challenges that are specific to Hawaii, and historical trauma, resulting in things like systemic barriers, conflicts in desirability and eligibility, and institutional distrust. So in the next few slides, I'm going to go a little bit deeper into this. So within Hawaii, Native Hawaiians, immigrant, and subsistence farmers all alike very much value their close relationships, their personal relationships, and rely on them for sharing information. Whereas policymakers, they rely very heavily on a top-down unidirectional flow of information. This becomes an issue as shared through my interviews and surveys that something that challenges a producer from being able to access resources is just knowing that they're even available. Another challenge is how we define producers. That may look differently depending on how locally we value those farmers versus how institutions may identify those farmers. In recent years, the NRCS has expanded their definitions to be more inclusive. However, that has yet to be reflected in the USDA's census data. Also, thinking about conflicting values between Indigenous and Western philosophies, there are challenges here. For example, the NRCS is very much concerned about conservation, whereas maybe a Native Hawaiian who's also concerned about conservation, but may be more interested in the biocultural aspect of that conservation work. And that can cause sometimes misalignments in what they value and how they want to proceed in their projects. Overcoming these kinds of barriers requires improved communication. So things like the NRCS can be working to do more community outreach and finding ways to incorporate community voices into their work. Going into some challenges, I found that those 4 categories, Native Hawaiians, immigrants, subsistence, short-term land leaseholders, and for probably many others, struggle with getting their basic needs as a farmer met. Those basic needs include reliable access to land, water, housing, healthcare, labor, pest management, access to markets, and many, many other things, all of which that inhibit their ability to be concerned about conservation programs. So it's difficult when these programs that are offered are not speaking directly to the local challenges that we're facing. Also, there's challenges in eligibility with strict conservation practice standards that don't make sense for how land use in Hawaii is done. And also short-term land leases is an issue with eligibility. Also, another challenge is in bureaucratic language or just language barriers in general that further complicates communication. And the last thing I want to mention there's a complex applications and paperwork is very overwhelming, and that was mentioned in all of my interviews and in many of my surveys. And so when their eligibility terms are not very clear, or when programs are competitive or awards are not guaranteed, it's difficult for these producers to find it worthwhile to apply to these programs. And lastly, thinking about the term historically underserved producers. You would think that it would include Hawaii's local histories in these terms, but it doesn't necessarily do that. So we should acknowledge what that history is. I'm going to go a little bit into it. It's very extensive, but to just touch a few things, starting with the 1848 Mahele, this pivotal land division transitioned us from communal land systems into the privatization of Aina and Vai, which set the foundation for foreign powers to acquire land in Hawaii. And this also influenced the rise of the plantation era, which replaced indigenous resilient ag systems with pineapple and sugar monocropping. And in 1887, the Breeanne Constitution was forcefully signed, giving Native Hawaiians a reduced political power. In the face of this, Native Hawaiians are having to navigate this foreign political system that was being imposed on them for the purpose of displacing them of land, water, and power. But also Kanaka and immigrant plantation workers were being exploited for their labor for building foreign wealth. So it's when these kinds of issues are at play that our local producers are facing challenges with institutional distrust. And when these institutions are responsible for these kinds of unjust histories and then are now trying to prioritize equity and climate, it's very difficult to do that without first acknowledging and holding the government accountable for these past actions. So further on in my work, the idea is to support that bottom-up communication and that bidirectional communication. So taking these contexts of all these challenges and then communicating it with different huis. I've already shared it with the Climate Smart Commodities hui. I've been working with them for the past few years. And then in the next few weeks, I also plan to be sharing with the NRCS, PIA, and they requested information about place-based research ethics and recommendations for improved community outreach. I will also be developing a policy brief to communicate recommendations to Hawaii state legislators. And to just go into conclusion, what those recommendations are, what I was really able to pull out of what I collected from communities, I developed recommendations based on that 5-dimensional framework of equity. So when it comes to distributional equity, I recommend an adoption of localized terms for historically underserved producers that target regionally relevant vulnerable populations. And within structural and intergenerational equity, I recommend the implementation and to implement accountability mechanisms that acknowledge and ensure generational healing from historical trauma. In terms of cultural equity, I recommend that they institutionalize local indigenous values and knowledge within their resource programs and eligibility standards. And lastly, for procedural equity, I recommend that they require culturally appropriate community outreach to inform the development of equity policies to ensure that they effectively target the needs of our local producers. That concludes my presentation. Mahalo. I want to give a shout out to Hauli Mauloa Foundation, USDA NRCS Conservation Innovation Grant, and the Hawaii Climate Smart Commodities hui for all of the funding and support and professional development that they've offered me throughout the last 2 years. And also a huge mahalo to all of my my local producer community.
We have time for questions. You can obviously ask Destiny directly, and Dr. Price will be seeing if we got questions online from the Zoom community. So those online, if you want to type up your questions, Dr. Price will be checking that, but questions from folks in the room.
In terms of the needs that you sort of identified, what do you think is kind of the most kind of detrimental legacy of that, like historic history that you mapped out? The kind of creating that inequity, what do you think is like the hardest of those, or yeah, of that legacy, the hardest to meet, or maybe that these agencies, in particular the federal agencies, would be like, have their hands tied if they're really trying to address?
That's actually, thank you for asking that question, because I forgot to mention, something that's really tangible that can be approached is within the Hawaii State Constitution, there are provisions that require the betterment of Native Hawaiians. And I think that leaving that unfulfilled is something that really keeps this institutional distrust to continue. So I think finding ways to invest in the Native Hawaiian communities to fulfill those provisions is definitely one way to overcome a lot of the challenges. Did that answer your question?
We planned that.
We do have a question online. What was your experience in researching socioeconomic disparity data within the agricultural sector?
Sorry.
I think it's asking about your experience. So what was your experience in researching socioeconomic disparity data within the agricultural sector?
My experience, it's a lot, but I mean, I think the most beneficial part of my experience was building relationships within that community and being able to understand the reasons that they resist support that is available to them, and also engaging in them. So not only just that, but other things with like those who are not even aware of the issues. So understanding where they are and figuring out ways that they could be better communicated to. I think that's probably a huge thing about the experience that I really appreciated. I don't know if that
And just a reminder that the audience member who asked it actually is going to
Hello.
be.
Sorry, yeah.
It's all very.
Okay. All right. Well, thanks so much, Destiny. Appreciate your presentation.
I think a number of students also are online as well. And so Destiny and others, if questions continue to come in to the chat, are you able to address those directly through the chat maybe? Just for the sake of time.
And just share with your.
Thank you so much. Appreciate it.
Guys, want to make sure folks are now looking at Noah's presentation as we're still. We have a clicker. I'm gonna grab one. The next presenter is Noa Ragone. I'll let him take it away. Grab the clicker.
Kind of want to wait for that clicker. Or I can start. Okay.
If your talk is short, then it's running full time.
I'll start. Okay, my name is Noah, and my capstone project was about correlating the current and potential ranges of Hawaii's declining native plant species on the Windswept Summit in the Ko'ola Mountains on Oahu. Specifically, we're looking at Pu'ukonahuanui. That's the highest peak in the mountain range, and it's more familiar than you might think. It's the peak right behind campus on the left side of the valley. Back when I proposed this project, I focused on two major things in terms of anthropogenic factors, which were invasive species and climate change. However, upon visiting the peak many times, I quickly found that this other factor, hikers, had a lot to do with the problems that we're seeing here in the mountain range. And that really gets into why I chose to focus on Konahuanui, or K1. I chose it solely because of elevation. It's the highest peak. We generally in Hawaii, we associate the highest peaks with being the most native habitat or the last refuge for these plants. And that's kind of not what we're seeing. At least that's not what I'm seeing. And you'll get that idea in a couple photos later in this presentation. So this project is based on a paper published by Lucas Fortini, who identified or went across all native Hawaiian plants and identified those with the highest risk, essentially saying that these plants have no habitat to exist in outside of where they currently exist. So I chose two on his scale that had the highest vulnerability scores. And one of those is right here, this Labordia, and the other one's right here. And I chose this one specifically because its endemic counterpart that also lives only in the Kupaʻa Mountains. It is listed as endangered. I'm not exactly sure. I wasn't able to find out exactly why the U.S. Fish and Wildlife Service did it this way, but the subspecies that I focused on is not listed as endangered. So this is the summit, the peaks down here on the bottom, and I focused on the three main aspects of the mountain. At least that's what I thought. But when I went up there to survey for these rare species, I quickly found that the west side wasn't what I'm looking at, that it's not windswept. The plants that exist up there are more than a meter high. So I quickly ruled that out and focused only on the north and east facing sides of the mountain. And I wanted to go back to this photo real quick so you can kind of get an idea of how challenging this work really is. But try to get a good look at this plant right here. And now tell me if you can see where it exists in this photo here. It's pretty hard to see. And now imagine that on a landscape-wide scale. If your plant ID is good, you might be able to pick a few things out. There's a couple of ma'u ferns in there, Hawaiian club moss, but the plant's actually right in the middle of the photo. And that's just how hard this work really can be to survey for these species. Now here's one more. I think this one's a little bit easier than the last. And before I point it out, I want to point out how everything in the foreground that you're looking at is Metrosideros polymorpha, or Ohia lehua as we know it. If these same plants had been growing a couple feet away on a flatter landscape, you'd be talking about an overstory tree. But that's where we get into what windswept really is. You're only a couple inches tall because we're talking about the windswept summit, and it's directly in the face of the trade winds. And there's that plant. They really are just that hard to find. So the other aspect of this project that I didn't anticipate until I got up there was this trend that I started observing more and more and more. So I decided to start recording the same information that I already was for the plants that I was focused on. And it's what I kind of called in my paper weed pockets, for lack of a better term. They're little areas along a steep summit in an otherwise really native habitat where weeds just seem to thrive. Generally speaking, these were little pockets of where the slope was less than 30 degrees, but everywhere else you're looking is almost entirely native plants. And it was something I just couldn't ignore after seeing it time and time again. And this is the Kahili ginger, one of the worst weeds up there, and the other one is palm grass. I wanted to go into a little disclaimer before clicking to that next slide, but there is some rare location information that had to be obscured. It was pointed out to me when we did our practice presentations. However, because this first species wasn't so rare, at least from my findings, these ones are not obscured, but I wanted you to see how many there are. And the circle up there is just to give you a reference point. That's just simply the summit. So basically what I did on surveying this section of the trail over and over and over was record this data, and in real time, because there's cell phone service up there, it would send back to my online ArcGIS account for me to do the work later, or now analyze the data later. But then you look at the lobelia, I only found 4 populations. Now, it doesn't mean 4 plants, like those 2 plants, but that actually means just 4 populations totaling 12 plants total. So going back, and then you see how much it just drops off. And to compare that with the aspect of that I wasn't focusing on, but I said, hey, if I'm up there, I'm going to look for listed species too, just to let the Plant Extinction Prevention Program know. I found more listed species than the one that isn't listed. In fact, 9 total populations of listed species. Specifically, this Trematolobelia, which I'm happy to say, I think the peak is quite a natural stronghold for the plant. And this is where I really get into the limitations of this work. Because I only focus on a 0.6 kilometer area across the summit, I gotta just say my data is very limited. I didn't want to bite off more than I can chew. I understand, and this is combining 2 species into one to try to get the best well-rounded data, and it still didn't really come out that great. Had I gotten the permits and used listed species, it could have been more refined, but that really wasn't, it wasn't what I was going for this project. However, what I found, at least for slope, was that they centered around 50 degrees, and for aspect, the majority of the plants fell around 75 degrees. However, when I expand that out just a little bit, 2/3 of my data and 50% of my data fell within those ranges alone, showing that there kind of is a sweet spot for these plants to exist on the windward side of the mountain. And this is really why it's a problem. So what you're looking at here is just a couple feet off the summit. All that is Kahili ginger. And why I said hikers are such a problem is because there are summits much lower, hundreds, almost 1,000 feet lower in the same mountain range that look nothing like this, almost entirely native. Except our highest peak in the mountain range, it's honestly hard to find a native species in this photo. Contrast that with this photo. If you were to tear through that ginger and look straight down on the windward side, you'd be looking here. And this is one of the listed species that I came across, the Trematolobelia. And that's just how stark the difference is from being on the trail, 5 feet away, looking down the windward side. That's how drastically it changes from completely invasive to completely native habitat. So I want to say there is hope. And then going back to this photo from earlier, what you probably didn't notice when I was pointing out the ginger in the corner is just next to it is an olapa tree, or sometimes called lapa tree. When they're not growing on the windward summit, they can grow several meters in height. That's just another example from elsewhere. It can be an overstory tree, but this photo shows the power of the wind. How much the wind can reduce it in size. And so what I think this is telling a story of is that there is hope out there. So many times in this topic of natural resources, we hear about how our forests are sick, dead, and dying. We throw around terms like climate change, invasive species. Everything's not going in the right direction. However, what I think this photo is telling you is that there is hope. These species that live over here, the Cyanias, the Trematolobelias, the Labordias, everything, the things that I focus on and many more, they're built for this habitat. They're made for this habitat. And the invasive species can only exist here when there is a break in the habitat for it to exist. That is not meant to be there. And if the topography did not look like that, it would not be there. So going into my recommendations, I think it would be unreasonable to say we should focus on the windward summit across the mountain range. That's simply just not reasonable. But what you're looking at here is a random area in the Kupaʻa Mountains that is actively managed by the Plant Extinction Prevention Program. I'm not going to say where it is, but it's just a random location. And that's where I would say I want to hope that we can focus on these areas on the windward summit. Since it's not practical to say focus everywhere, let's focus on places where we already have boots on the ground. And then going into the recommendations of the land manager that I worked with, her name is Susan Ching. She works with the Plant Extinction Prevention Program. She said, in summary, if she could, she realizes how bad of a problem the Kahili ginger is. And she said she wishes you could just aerial spray for it and get rid of it. However, she followed that up by saying, we simply don't know what's on the ground. She used the word ground truth to talk about how important it is to have boots on the ground. And that's what you're looking at here. As easy as it would be to spray for this ginger in the back of the photo, you don't know what's there until you're actually standing there. And right here, you're looking at one of the Kupaʻa Mountains' rarest and endangered species. It's a Cyania that only lives in the Kupaʻas. I'm not even sure if PEP knows it's there, but at least they know it's there now. So as much as we would like to just manage these landscapes on a large scale, I think this shows, even from my limited data, that how important boots on the ground is for this type of work. Thank you. Do you have any questions?
Yeah, we have time for questions, folks.
We have 2 questions in the chat, so maybe we'll start with the first one
Sure.
of those and then take
Okay.
a question in the room,
Sure,
then
sure, I'll let you-
the second question in the chat.
Yep.
So first question is, what is the typical slope or aspect on these hills? How does the distribution of the plants of interest compare to slope aspect at random?
So the first part of that question, the average, it's quite variable, and I think you can kind of see that from the photo here. I mean, it can go from straight down 90 degrees and almost to 30 degrees as you were seeing in that weed pocket, but an average, somewhere like around 50 to 75 degrees seemed like the average, at least for this peak specifically. And what was the second part?
Slope and aspect, and then how does the distribution of the plants of interest compare to slope aspect at random?
That's a hard question to answer, at least for the lobelia, because it just seems to be growing in the most random places. I have obviously a 0.6 kilometer area is just not telling for the entire mountain range. It never would be. So we'd have to survey much more. So I'm not really sure how to answer that, I guess. I guess what I wanted to say and follow up with is that I think that there's a follow-up study that could be done here to focus specifically on plant height. If I were to do an additional study, I'd focus on plant height and focus on take native species on the windswept summit and take invasive species and compare those. And I think that would be a lot more telling than what I'm already finding or than what I observed doing this project.
Question in the room?
Yes.
Yeah, I think I heard you say one sentence related to hikers and didn't,
Mhm.
you know, help me understand what the relationships of that is. The hikers.
Has to do with tracking in invasive species into habitats they shouldn't be. So I got to hear a lot from somebody else sitting in this room about how he only flies into the habitat that they work in on Maui. So they don't hike up there and drag those seeds up from a lower elevation that are invasive seeds.
So they're dragging up on their float.
Mud, everything in the soil.
So another online question, what might the impacts of conservation access be in a place like this? And how could those be offset? What would you, and as kind of as a follow-up here, what would you suggest to manage hikers and the impacts?
I'm not sure what can be done to manage hikers and their impacts. Hikers kind of go wherever they want. Stairway to Heaven's in the news a lot right now, and people will still continue to hike that mountain. So I'm not sure what can be done to manage hikers. What was the first part?
What might the impacts of conservation access be in a place like this, and how could those be offset?
Conservation access. Does that mean like restricting people from visiting conservation areas?
I'm not sure exactly what was meant by that.
I meant just going to conservation activities, which is obviously necessary. But how do you sort of balance those with impacts as well?
At least for this extreme environment, I'm not sure about conservation activity. It's kind of hard to ask people to hike up and take part in conservation activities in an extreme environment like this. Generally speaking, beach cleanups are very accessible to people. This is not.
I'll ask a quick question because we've been back and forth on this. Thinking about you've kind of identified some areas that would be suitable to find for these populations to exist and to beat back the invasives. I mean, is this something that could be expanded to? This is where we need to look. This is where we need to think about hiking trails, access, you know, so that we just sort of protect them by not encroaching on them.
I think both.
Okay.
Yes, it's where we need to look. And me pointing out populations that PEP had no idea about kind of hits on that. So there's no shortage of needing to look that needs to be done. These mountain ranges are so rugged. There are infinite number of drainages to look in. But as for hiking trails, I hope they are where they are and they stay where they're going to stay and we don't keep building new ones, because if we keep building new ones, that's just inevitably going to attract more invasive species up to the summit. And like I said, there's many other lower elevation peaks that are quite pristine compared to the highest peak in it because of hikers.
One question, quick.
Yes.
Any sense of what your like search time relative? I mean, I think that's kind of important for people to understand.
To finding a plant?
Well, yeah, we're like, yeah, total, like when it took you in terms of survey time and what you're able to.
Probably 6 hikes total, I think is what I did up there. But 2 hikes in the beginning were the most telling. And then when I was like, I'm gonna find more today, I'm gonna find more. The last couple hikes, I was seeing what I already knew. And it's just really a struggle. And I think that's sad to say for the lobelia. I really wanted to find more and I could not. I don't think there is more.
Well, you were also saying it's a rare day, it's a clear day up there as well in those windswept areas. So not every hike is gonna come out.
Mhm.
Yeah. Thank you. No, I appreciate it. Good on time. We have a couple of minutes, so if folks want to do a quick stretch legs, use the restroom or something. We got a couple minutes before our next, before Willie, I think.
And by a couple.
Two, we're starting 2 minutes. Yeah.
Or wait. I was like feeling so casual. Right now, I'm like, oh, sorry. After I saw you, I went up to the Mejana's people lab and I just like went over my side one time. I was like, that was hard. Don't stand up there and then forget what you want. Yeah. Is mine hard left there? Well, I just did one.
So you are, hang on.
I'm right after.
Yeah, you're after Willie. Okay, I mean, you're,
I think it's. I just get thrown up there, like, surprised, I'll be like. I think that's why I'm always like, the long.
you make a couple small changes.
I just moved one of the slides. Okay.
Yeah, it's online, it's updated automatically.
Sweet.
Okay, very good. All right, thanks, everyone. We'll start with our next presentation.
Where's the ideal place to go?
Kind of right there.
Put you up to.
Oh. Okay, I'll just present to you guys.
Sorry, yeah.
It's like way less pressure. Yeah.
That way.
No.
Or slideshow.
I think I actually, now that you brought the date, I'm like, I don't need. Are you here for 6:11?
Just-
Yeah. Oh my goodness. Okay, so you're just.
Speaker view.
I know. Hold.
Oh, sorry, hang on. Oh, sorry, it's already doing this. Okay.
Got it. 'Cause no one wants to.
Is that what we're sharing?
Yeah, oh no,
No,
I still see.
you're still saying, oh, shoots. Okay. It's trying to, we're only seeing, we're seeing your side, not that side.
Oh, on Zoom.
Yeah,
She's the.
you see now. No, same thing. Sorry, folks, we got our sharing screen here is.
This is coming out on Zoom perfectly well right now.
Is it? Okay.
Yeah,
All
we're
right,
looking
good.
at the right thing on Zoom right now.
Oh, perfect. Okay, yeah, because I'm looking at the slide presenter view here, so we're good.
Online, we're looking at the slide itself.
Okay, very good.
It has to do with which screen you're sharing, but.
Okay, thanks, JB. All right, go ahead.
All right. Aloha, everybody. Thanks for coming today. My name is Willie Carter. The title of my capstone project was Fire in the House of Water, Monitoring the Impacts of Wildfire on Native Forests in West Maui. Big mahalo to my committee members, JB Friday, Travis Idle, and Kimberly Thayer.
I have to click on the screen.
Yeah, message, yeah, it may not be working. Sorry about that. That's all right.
Can't get it to change slides.
Oh,
We have to click on here.
there we go. Okay.
Where'd you click?
On the actual next slide.
All right, sorry about that. So we begin here in the beautiful native forest of West Maui. This rugged terrain, commonly referred to as the West Maui Mountains, also goes by its Hawaiian name of Mauna Kahalawai, which roughly translates to the House of Water. From the summit of Pu'ukakui at around 5,800 feet on down to around 2,800 feet in elevation is home to some of the most pristine, intact native forests that we have left in Hawaii. It is home to many endemic species that exist nowhere else on Earth, and new species are still being discovered up there to this day. such as this Claremontia hanuilaensis in the top right corner, discovered by Hank Oppenheimer just a couple years ago, and just a couple ridges away from my study site. Like much of our native forest in Hawaii, this area provides vital watershed function to the island of Maui and roughly 70% of its drinking water. And like the rest of our native forests, it's facing severe threats in the form of invasive species, climate change, development, and now wildfire. So in November of 2022, the Kaua'ula fire was sparked in the foothills above Lahaina, roughly where the Lahaina fire started last summer, except this fire moved Mauka instead of Makai. And it burned over 2,000 acres of various ecosystems across a 3,000-foot elevation gradient, ending on Helu Ridge at around 4,500 feet in elevation in pristine native forest that has never burned before. This figure here on the right, on the bottom, shows the footprint of that fire in blue, as well as a previous fire in red and where they overlapped in purple. You can see that the 2007 fire ended much further down in elevation. And sorry, Lahaina's to the left, going upslope to the right. The green area on the map shows the 50,000 acre management area of the Mauna Kahalawai Watershed Partnership. I had the good fortune of working with this great organization for a number of years prior to my master's program, working hard alongside an inspiring group of individuals doing invasive ungulate control, invasive plant control, fencing projects, long-term monitoring projects. Just spending hundreds of days in these mind-blowing places. And not only is it tragic to see this irreplaceable forest loss, but it's hard to see all that hard work go up in smoke literally overnight. So, oops. This is just to show you the intensity of that fire. This is the top end of the burn in the center of the photo. It's what the forest looked like prior and post on the right. And that it was that level of devastation for 2,000 acres of land. So let's put this into context with a little bit of background on wildfire in Hawaii. Historically, prior to human intervention, wildfires were practically non-existent here, save for the small, low-intensity fires sparked by lava or lightning on very rare occasions. But for the most part, our ecosystem did not evolve with wildfire. And this figure on the right here is showing this dramatic increase in the last century in wildfire activity and total land area burned, correlating with the decline in plantation era agriculture. Suggesting that perhaps that chapter of history was maybe a good thing for the land. But if we put this in a bigger picture, what this figure is really shown is kind of the culmination of a legacy of bad land stewardship following colonization. All the land that has been cleared, all the massive scale re-engineering of our surface water dynamics that promoted this period of agriculture, as well as all the invasive species that it brought in. And what we are left with now are these vast areas of unmanaged land in private hands, overgrown with highly flammable invasive grasses. Zooming in on Maui, this is fire activity in the last 25 years. And if you know Maui, you know this is all old ag land. Adding on top of this, the 99% of wildfires in Hawaii are started by humans, whether it be a cigarette or a power line. We can't be calling these events natural disasters as we see in the news. This is a totally man-made problem that's now being exacerbated by climate change. And the driving force of this phenomenon is what is known as the grass fire cycle, widely documented across the Pacific Islands that are facing similar threats. In a quick nutshell, fire starts in these unmanaged grasslands, encroaches on the forested areas, goes out. Fires are quickly reseeding and resprouting and outcompeting a lot of species, and the grassland expands. Another fire starts, and the cycle repeats itself in this positive feedback loop, leading to the erosion of our native forests. And the Kaua'ula fire was a particularly extreme example of this cycle in occurring during a severe drought. It moved way beyond this interface. And we didn't know how the native forest in the far reaches of this fire was going to recover on its own. So, brings me to my project. The objectives of my project were to determine how this pristine ecosystem on Helu Ridge responded to this novel wildfire disturbance. I wanted to obtain data on the initial passive recovery and ecological succession in hopes to guide management responses to similar disturbances in the future. I also wanted to examine the difference between single and repeat disturbances by incorporating that 2007 fire line and just contribute to the growing body of wildfire science in Hawaii. So my approach was to collaborate with the Maunakahaʻawai Watershed Partnership to establish a monitoring project for this remote area. Now keep in mind, there's no trails or roads going in there. It's all helicopter access only, and the weather is very unpredictable. So it kind of changes your approach to things. What we came up with is a photo point methodology for ground cover. And the intention was to find the quickest way to document as much of this area as possible in a consistent, repeatable way, in order to take advantage of these rare opportunities for access. And what this looks like, what I came up with, this figure is showing Helu Ridge, again, going up in elevation from left to right. The red is just a general outline of the 2007 fire. The yellow is a general outline of the Kauaʻula fire in 2022. I established 8 plots in the burn zone, with 4 of those plots being in once burned forest and 4 of those plots lower down in twice burned forest. And I established a control plot, which was more of a reference in the unburned forest above the burn zone, to show what the forest was like prior to the fire. And this plot was inventoried using the organization's long-term monitoring methodologies. Within the burn zone plots that I established were 3 subplots of 4-meter diameter circular plots for a total of 24 samples of the forest moving down the ridge. And it spanned about 1,000 feet in elevation. And what those plots entailed in the burn zone was pretty simple. From the center point, I ran a tape measure across the slope, roughly perpendicular to the slope. Took a compass bearing so that I could repeat it in future visits. And at each subplot, set a tripod to a standard height, looking straight down with a fisheye lens, and just took 1 picture for each subplot. And along that tape measure, I put flagging to mark the 2-meter radius circle, so that afterwards I could just overlay a circle, and then I calculated 5, 10, 20% of that, so I could do a general visual estimation of various ground cover types within each one of those plots. I broke those into general categories because my intention here is to kind of tell the story of this invasion cycle, not necessarily document specific species, although I did catalog all of that for the plots. So 5 categories were native vegetation, non-native vegetation, invasive grasses, dead litter, and bare ground. And this is a sample of what that looked like. The photos on the left are from the once burned forest in the upper plots. This is 9 months out. This is 16 months out. I was able to get in, I should have mentioned, 2 times, 9 months and 16 months post-fire. And then the photos on the right are a sample from the lower twice burned forest. Top photo is 9 months, bottom photo is 16 months. So moving on to just the control plot. This is essentially, I just wanted to highlight how healthy and intact and diverse this forest was and still is above the fire. So 1 photo just to show you that, and then this the table on the left is a sample of the data sheet that the partnership uses for their monitoring methodology. And this is the difference here is that this is well over head canopy. So the ground cover methodology that I use in the burn plots doesn't apply in here. But what we found in a nutshell were 16 different native species within that plot. 1 singular specimen of a non-native species, a Philippine ground orchid, and then overall 97% undisturbed ground cover. So again, just highlighting the healthy nature of that forest. And then now moving on to the burn zone plots, which were the main focus here. This figure here for 9 months post-fire shows elevation gradient on the bottom on the x-axis moving from low to high. Each point is one of the plots. The y-axis is percent cover. Broken into categories by color, we have green for native vegetation, yellow for non-native vegetation, red for grasses, gray for dead litter, brown for bare ground. The orange dotted line represents the 2007 fire line elevation. So everything to the right of that is showing once burned forest, and everything to the left of that is showing twice burned forest. And the main things to note here, we had minimal regrowth overall in the upper once burned plots 9 months out. And then as soon as you bump down below the 2007 line, you see this explosion in non-native species and invasive grasses. And it remained largely bare ground at this point above that. This is just a simpler way to visualize that broken down into vegetation. I averaged for the once burned and twice burned plots, showing non-native vegetation in orange, native in green, and then the figure on the right is simply invasive grasses. 16 months out, unfortunately, had some really strong winds that day and they canceled all flights out of the mountain. So I had to hike all the way out, which didn't leave me time to complete all the plots. So, but I did get 3 done in the once burned forest and once done in the twice burned, which is enough to kind of see some general trends developing over time. And clearly, the most important thing to note here is that now we have grasses moving into those upper once burned forest plots and a lot more non-native in general. And the dominant species for the rest of those non-native were fireweed and thimbleberry. Among many others, those were just kind of the dominant ones. They say a picture tells 1,000 words. This one sure does that. This is a screenshot from a video on the flight in 9 months post-fire. I was able to align it with the elevation on the fire footprint map. So what we're seeing here is twice burned right next to once burned at the same elevation with that kipuka of unburned forest in between. So it's just kind of 18 years of disturbance history in one photo right here. And you can see that the twice burned landscape on the left is completely covered in grasses and weeds already. And the once burned is all bare ground still. So what does this all mean? The Kupaʻa fire was unprecedented, and I know we're all sick of hearing that word, but better get used to it because it's the new precedence. And really highlights the need to get in and document these initial occurrences, as we're bound to see more of them moving forward in the future, so that we can start developing some sound focused strategies for mitigation and response for future events. And what we saw in this through my results is that one fire is not necessarily the end of the world. We have this window of time to get in there and take advantage of that sort of blank canvas to work with. And before the grass really takes over, we had majority bare ground for the duration of my study and higher diversity of native regrowth. And then that repeat fires really reinforce this invasion cycle, and your chances for restoration decrease significantly. And then again, highlighting that these remote areas require really effective, efficient planning and strategizing for any restoration efforts due to the logistical challenges involved. And in my opinion, it shouldn't all be falling on one singular organization, such as the Mauna-Kahala Watershed Partnership or others around the state. There needs to be a statewide collective vision here moving forward. Big thanks to the Mauna-Kahala Watershed Partnership. I could not have done this without them. And to the University of Hawaii for supporting me through this. Thanks to my advisor, JB, and panel members, Travis and Kim. If you want to learn more about wildfire in Hawaii, you can check out these 2 great organizations, Pacific Fire Exchange and the Hawaii Wildfire Management Organization, or shoot me an email. And thanks for listening.
Thanks, Billy. We have time for a couple questions. So any online mute just yet, or anyone in the room right away?
Folks online are putting them on in. So
All right, we'll start with them. Thanks.
first of all, did you record the species of invasive grasses up there? Was it mostly molasses grass and Pogon virginie?
Yes. Yes, I did. I did record all the species that were present, and it was a lot of molasses grass, a lot of Andropogon virginicus, as well as Andropogon, or no, what is it? Major, drawing a blank right here. Yes.
Maybe
In a nutshell, I
follow
have
up with
it all recorded. And is there a follow-up to that?
There's a second question. Unprecedented is the new precedent in quotes. What would you recommend for restoration post-fire in remote, sometimes deep areas, and to protect surrounding pristine forests from invaders and burn plants?
you repeat that, please?
What would you recommend for restoration post-fire in remote, sometimes steep areas to protect surrounding pristine forests from invaders on burned lands?
Yeah, and obviously it's very situationally dependent. Every location has its unique variables. What I can do is speak to my experience.
Speak to your.
Oh,
questions.
sorry. Sorry, yeah, so everywhere is very unique. Here in Hawaii, we have a lot of microclimates and diverse terrain. What I can do is speak to what I observed and experienced. And to the importance of documenting these things, having that clear view of where that overlap of multiple disturbances is. And in this situation, I would kind of target there and branch out. Yeah, it's just like it's so dependent on what resources you have, manpower, all that kind of stuff. But if you're limited, I would focus on that transition line between the multiple disturbances, because the species well above that had a fighting chance on their own and were doing pretty well. And that transition zone seemed to be really where it was all like, that was kind of the critical point in my mind for restoration efforts.
You have a question here in the room?
Yeah, so from the graph you shared with us, it seemed that non-native species were the quickest to bounce back, and so has anyone looked at, do you have any information if what the timeline would be through human intervention? How quickly native species can, repopulate that affected area, if they can can get in there quick enough before the non-natives have that chance to bounce back?
Yeah, again, it really speaks to the difference in once single or multiple disturbances, and where you plant, like, and what came back on its own. Like, I can say that from this site, Ohia, Ohelo, Alpaca, those did really well on their own without the grass already encroaching on them. So if you're going to be planting in total bare ground, whatever you can get in there that's like ideally at seedling stage, not seed, that is going to have a leg up over the grasses, go for that. And then down low, obviously where the grass is already blanketing the landscape, it's a different story. You're gonna a lot more work on your hands.
All right, thanks, really appreciate it. Yeah, sure. Thanks. All right, so next speaker is Aaron Wehrman, and so let's hide these controls here. So.
Oh, it's
Sorry.
It's showing on Zoom.
Yeah.
Oh, it's on Zoom?
okay.
Okay.
Right now you're not.
All right. Okay, so why am I still seeing?
I think it's because the monitors are still there.
Okay, there we go. Okay, all right, let's share screen. We can. There we go. There we go.
Travis, that's backwards. It was right. That's it. That's what we want now.
Yep, okay, we're good.
Okay.
Thanks.
Thanks, JB.
Bye, go ahead.
All right, good afternoon, everyone. My name is Aaron Wehrman, and alongside Dr. Idle, Dr. JB Friday, Dr. Doug Jacobs, Andu Wirabrana, and the help of Kuli'i Kamara of the Department of Flying Homelands, we're working on a project looking at the effectiveness of reforesting koa by crushing gorse rows in a gorse thicket on Hula, Hawaii, Big Island.
We have to click on the thing there. There you go.
Oh. Oh, now we're going back. There we go. All right. So the Department of Hawaiian Homelands manages thousands of hectares of land on the windward slopes of Mauna Kea in a place known as Humu'ula. This is shown on the map in the top left corner as the green shaded region in the red circle. So this land was previously leased out to cattle ranchers for grazing, and the trees were cleared and it was left to be a pasture land. However, about 30 years ago, the lease was ended and the land was mostly left to rest. And this really opened the doors for gorse, and gorse is a common pasture land invader. It's very invasive and it's from Europe. It's thorny, it can reproduce really fast. The seeds last in the seed bank forever. It regenerates really quickly. Can't emphasize that enough. And it can survive sub-freezing temperatures, and it's thorny. So ungulates don't eat it, nothing wants to go through it. And it can survive the freezing nights up at this elevation. And it's really hard to get rid of. So there's been many attempts, herbicide, crushing, shading, biocontrol. And unless you're doing this over and over and over again, gorse is just going to grow on back. So it's not very economical to keep coming in there, keep trying to remove it. So the new idea is maybe we can put something else with the gorse. And so the Department of Hawaiian Homelands wants to increase biodiversity and productivity of the land by planting koa up here. And another side note is that this could possibly help with sustainable koa harvesting, and that it could generate funds for programs on the Department of Hawaiian Homelands. As you guys know, they deal with a lot of housing, and this land is obviously not suitable for housing. So they want to help out in any way that they can to their cause of this. So by potentially generating funds and bringing biodiversity and productivity to this landscape, they could potentially make the best of this land without leasing it out and making money from the cattle ranchers. So to do this, in May of 2022, they started the koa reforestation project. Now to do this, they bulldozed 8 rows in the gorse, and 4 of these rows were treated with herbicide. So they did half the rows because they wanted to see if herbicide would make a big difference, and if it was economically worth it to do it in the future if they decide to go larger scale on this project. And koa, sugi pine, and redwood were planted. So this picture on the right is the seedlings right before they go into the ground, and you can see the gorse crushed row in the background. And here's a nice map of where the plot is and a satellite image of what the gorse. So the gorse is the dark green with the yellow flower, and those are the rows going in it. But one problem that they saw with this project is that the site is at 2,000 meters of elevation, and this is at the upper range of where koa can be found naturally, and it does get below freezing at night. But there was a previous project done in the same area where Dr. Kyle Rose had sugi pine that was previously planted, and he wanted to look and see if the sugi pine would make a warmer microclimate for the koa to be protected from frost damage. And now what he found is this figure on the right side, that the absolute minimum temperature increases when canopy cover is increased. So on this figure on the left side is a closed canopy, and the absolute minimum temperature is around 1 degree Celsius. And on the right side is a completely open canopy where it gets below freezing. So there's about a 2 degree difference based off of how open or closed the canopy is. And we wanted to see, although gorse doesn't exactly make a canopy, maybe it can provide some insulation or some protection to make a warmer microclimate for the koa. So there hasn't been any studies on this, so that's what we wanted to do. And also, we don't really know what's going to happen. How is the koa going to do? How's everything going to grow? Is it going to survive? So that's what we wanted to look at. So our main objectives are to test the effectiveness. And to do this, we want to examine the survival rate of the koa, the growth rate, the gorse regrowth, and the temperature inside the plot. And then with all of this information, we can give it to the Department of Hawaiian Homelands, and they can kind of decide, is this method something we could do on the larger scale across the thousands of hectares of land that they have up there. So where we came in is we went in and did annual height measurements. Drone imagery was also taken by BISC, by Nathaniel Friday. That was done right after planting, 6 months and approximately 2 years. And so this image on the top right-hand corner, that's what the drone imagery looks like from Nathaniel. And to track the temperature, we put in 20 temperature sensors laid out throughout the rows. We put 5 sensors per row. The first winter, we had them at 70 centimeters, kind of in the frost zone where the seedlings, how tall they were. but we didn't get that many freezing temperatures, and I'll talk about that in a second. So we really wanted to see if there was a correlation between where the sensors were placed. So we dropped them down a little lower, hoping for more freezing temperatures. So in the second winter, we put them down to 50 centimeters. And this data was taken every minute between January and March of 2023 and 2024. This is a map of where we put the sensors. So it was replicated 4 times in rows A, B, C, and D. There were 5 sensors per row. We have a control, which is on the outside in a clearing adjacent, just outside of the row itself. And then the 4 sensors we have inside, we have 1 right in the middle of the row. Sensor number 2, which is 1 meter from the middle. This is in line with where the koa were planted. Then we have sensor 3, which is in the barrier between the gorse and the row, just right where they meet. And then sensor 4 is inside of the gorse itself. We wanted to see if it would insulate it. And I would like to thank JB for risking his body for climbing into the gorse and putting it in there, because it's really not fun. So here's some images from the site itself. This image on the left is just what it looks like looking downslope. We have Mauna Loa in the background, Saddle Road's down there. And on the far left side is Hilo Town. And in the middle, this is what the gorse row looks like. The idea was to leave a little bit of gorse wood there, because we thought that it would stop the resprouting process a little bit. Gorse is not shade tolerant. So the idea was that by stopping the sunlight, maybe it would slow down the growth a little bit. There's a nice little koa seedling in the foreground also. And then on the right side, those are what the temperatures look like. So closest to the foreground, we have sensors 1, 2, 3, and then in the back, in the gorse back there, that's sensor 4. So for some of the results, for the first year, there was an 82% survival rate. So that was for the 495 koa seedlings that were planted. So we had 404. The second year, we lost a couple more, bringing it down to 71.2%. And these koa seedlings grew about 102 centimeters a year, which is pretty good for koa considering the temperature and everything they had to deal with up there. This picture on the bottom is what the koa looked like in March. So they're doing really well. The conifers are slowly getting that taproot in the ground, slowly getting there. That's the best looking conifer on the top right. And you can see the gorse in the background. That's kind of how tall the gorse gets. So the gorse is really closing in, and we're really hoping that the conifers are going to be able to pop their heads out before the gorse comes in. But you can see that the koa are well out of the range of the gorse, and they should be just fine. Some things that took some of the koa down. Ungulates tend not to go through the gorse. So we only have 1 fence, and that's access for us to get in. But I guess that fence wasn't dense enough, and some sheep were able to get in and did a little bit of damage. Also, wind took down some of the koa. As I mentioned, there were some gorse wood left on the ground, and we think that this might have stopped the koa from being able to get their roots in really well. So some of them fell over, some of them were bent. There's some light psyllid damage, and between that pretty much explains the survival rate there. For the gorse regrowth, after 2 years, the average ground cover went up from 0% right after we bulldozed it to about 17%. And here's where we wanted to see if herbicide made a difference. So the rows with herbicide had a gorse ground cover of 14%. Without herbicide, it went up to about 20%. So it showed that the herbicide did actually do something. To give you an idea, there was a lot of growth between years 1 and 2. After the first year, there was only 3.5% ground cover of gorse. But after the second year, it kind of shot up to 17%. And after having gone in there in March and April, it got really difficult to get back into the plot. And I can see it being a problem as it gets closer to being filled in all the way. So this is what Pandu was able to do with the drone imagery. He did a maximum likelihood classification and was able to show the gorse and the land and how it was differentiated. So here we have 56% gorse and 43% land. This was taken right after it was bulldozed. And then 6 months later, it went up to 61% gorse versus 38% land. Some of this was due to the density inside of the gorse, probably having to do with the weather and the moisture and how the gorse was able to grow. But in the future, this is something that I would like to take a closer look at and maybe make a mask inside of the rows and look at that specifically and compare the herbicide versus non-herbicide. But here's the temperature data. So we expected to see it to be warmer inside of the row than outside of the row, but we found the opposite. So what I was expecting to see here is that the sensors on the bottom, we have AC, BC, CC, and DC. Those represent the controls. So we were expecting to see the most amount of freezing temperatures there. So this graph shows minutes spent below freezing. The numbers on top are how many minutes were below freezing. The first winter, none of the controls got below freezing. They were all found inside of the rows, primarily in row D. And row D, the plot is at a little bit of an incline. Row D is at the bottom. So we would expect row D to be the warmest as it's the lowest altitude, but that wasn't the case. And looking at the absolute minimum temperature, that came at center D3, and it was negative 1.42 degrees Celsius. And the control at the same time was at negative 0.77. So if anything, it was the opposite. And winter 2 just showed that even more so, where the absolute minimum temperature got down to -4, and yet it was negative 0.82 at the control at the same time. And this graph, although we did get some freezing temperatures in the controls, pretty much came out to be the same thing as the first winter. So this also showed in the sensor location. So this takes out the row and just looks at sensor location. So sensors 1, 2, and 3 were all about the same, and they were colder than sensor 4 and the control. So sensor 4 makes sense because it's inside of the gorse, right? So we'd expect it to be insulated. But again, we have the control to be the warmest. And then that showed the same thing in the second winter. And just to clarify, this average temperature is only at night. So it's between midnight and 5 a.m. So survival rates were pretty good considering the ungulates got in and the wind damage. However, the rose study that planted the koa underneath the sugi pine, they had a 90% survival rate. But those koa trees were pampered a little more and they're a little bit less. So that could explain that. Herbicide did show some slowing to the regrowth, so that might be something good to do in the future. The drone imagery is a great way to show what is gorse and what is land, especially once the gorse is impenetrable and it's really hard to get in the plot. It's a really good way to see what's going on in the field. Also, so our hypothesis was not correct. And we've been talking about this a little bit. And an idea that came across is that the rows are disturbing the natural airflow. So whereas the wind would normally swirl around and move, change the temperature, these rows created a little area of less wind for that cold air to just like settle down in and stay there throughout the night. So we're thinking that's one reason why it came to be colder inside of the row. We also found that plantings could be potentially done earlier in the spring. So something I didn't mention is that none of these freezing temperatures came in the month of March. So that kind of showed us that after February, we're pretty much in the clear to plant. These original plantings were done in May. So maybe we could push it up to March where it's a little bit wetter. We don't have to worry about the drought of the summertime and hopefully lead to even higher survival rate. So to conclude, the rows did not show warming, but the koa is growing pretty well. We learned some things that could be done in the future if this was to be replicated. These koa trees did not have frost damage because they were able to grow fast enough to where they were out of the frost layer. Ungulates are staying out of the gorse, which is nice because it saves a lot of money on fencing. We can just keep the gorse as a fence and have one fence as a way for us to get in the plant. And it really does make the best out of this gorse-stricken land. Right now, if you go out there, it's just a big blanket of gorse and that's about it. So this could be a great way to diversify the landscape. And here's a really nice picture I like to look at. Other things are coming back too once we clear out the gorse. Here's a little fern. We had some akala, some native Hawaiian raspberry popping up. So we have a bunch of stuff coming into this land once we're able to clear it out. And again, the koa is looking really great. Some people I'd like to thank, of course, are Dr. Idle, Dr. JB Friday, Dr. Jacobs, Kupaʻa with the Department of Fine Homelands. This wouldn't be possible without their help and their access to the land and all that they've done planting the koa and bulldozing. Also, we had some volunteers coming out. We had to measure 500 trees every year. That was a lot, and we needed help with that. Nathaniel Friday with BISC for flying the drone and getting that data, and Pandu for going through the drone data. And I'd especially like to thank Haoli Maloa for funding my education. I had a really great time working on this project, and I wouldn't be here if it wasn't for them. So I'd really like to thank them for that opportunity. So does anybody have any questions?
Thanks. We have time for a couple questions. Yes.
How do you harvest the trees? This presumably after 20 years, the gorse is like a thicket.
Yeah. So they would definitely have to bulldoze in. One other thing is we're hoping that the conifers grow up and create a little bit of a canopy cover for the gorse. And that should slow them down a little bit because it'll create shade underneath. So that's one reason why the conifers were also planted.
Yeah, the shading aspect is really interesting. That'll be nice.
Yeah. Oh, yeah.
Any online questions?
We don't have any online questions. I might ask a question. So I'm aware that some of the redwoods and pines and things can be invasive in some areas. Is there, I don't remember you saying the rationale for the choice of using some outplanting some non-natives in addition to koa.
Yeah, so Sugi pine's already up there. There's been previous plantings. And again, it survives well in that climate, and we're hoping for that canopy cover. And I don't think they're too worried about it becoming invasive. And it's shown that in the past that Sugi pine and koa do pretty well together.
Great. Thank you. Appreciate it, Aaron.
Thank you.
Sorry.
Erin, there's a question that came in.
Yeah, what was the transition? Go
You
ahead.
can answer online.
Okay.
All right. You on PowerPoint or online? Google Slides.
Oh, okay, good.
No, where are you at?
Oh, it's in the folder.
Oh, sorry. It's in the phone. Okay, we can open it up.
Above.
Oh, okay, there you go. Okay. All right. You seeing Kupaʻa's presentation, JB?
Now you're on the presenter mode, not the presentation. There you go. That's the
Okay.
presentation.
All right, hide the meeting controls, click on here, oh, and you should be able to use this. All right, so Kupaʻa, he is our next speaker, so take it away.
Okay. Aloha, good afternoon. My name is Charlton Kupaʻa. Presenting my capstone research, Where Kahuli Wander, Climate Change and a Hawaiian Tree Snail. I'd like to thank my capstone panel for their kokua and guidance for the past 2 years. I'd also like to thank the slew of people that have volunteered and been a part of my research, as well as the partner programs that have been a part of the research as well. It took many hands to complete this task, and I'm thankful for each and every one of you. I'd also like to say thank you to Hauʻoli Maoloa for funding my education as well. For the past 9 years, I've been a field technician with the Division of Forestry and Wildlife's Snail Extinction Prevention Program, SEP for short. During those 9 years, I've had the privilege of working with kahuli, also had the kuleana of working and witnessing extinction events in real time. One of them being this population here of Acatinella concavospira. In 2016, a population in the southern Waianaes was inundated with rosy wolf snails, Euglandina rosea, one of 3 predators that are pushing kahuli to extinction. The other 2 being rats and Jackson's chameleons. In this site, SEP decided that we would return weekly to remove Euglandina by hand. This was the only feasible method due to slope and terrain. This went on for about 8 months or so, and we realized that this was not a viable option. We had to actually evacuate the remaining kahuli, and that's a picture of me safely climbing in a tree to get some kahuli out of the canopy. By that time in 2017, SEP had recently established a captive rearing lab, and all of the individuals were moved into this rearing lab and have been there for the past 7 years. The question now is where do we put them? They've been growing and reproducing in captivity, and typically SEP will be releasing reared individuals back into their historical range in protected areas, predator-proof fencing. I'll refer to them as kipuka kahuli from now on. And you'll get to see a bit of that later. But in the face of climate change, managers are now asking the question, like, is it feasible to introduce Kahuli back to their historic range if models are now predicting that these areas are going to be unsuitable for them in the future? Just a short little run through of historic ranges and how dynamic they are. These changes in species ranges occur through a time scale that allows for organisms to migrate naturally from one area to the next through the overlapping climate envelope of their current habitat and climate suitable habitat, allowing for the fringe populations to then move into suitable habitat as conditions change. However, in climate change future, these dynamic shifts are happening at such a rate that climate suitable habitat is becoming fractured from current ranges. And in these cases, human intervention is needed to ensure that organisms maintain a presence on the landscape through conservation introductions. That's taking organisms from their current range and introducing them to climate suitable habitat outside of their historic range. On an island scale, island endemics and climate change, we're seeing that climate suitable habitat is actually migrating up in elevation. So in the Kahuli's case, they've evolved in niche ecological zones and are being marooned as climate change moves that climate suitable habitat upwards in elevation. So we come back to Acatenella concavospira and the southern Waianaes. They're in yellow, overlapped by the blue. You see Acatenella concavospira's historic range. They share this space with a sister species, Mustelina, whose historic range extends from southern Waianaes all the way up to the northern Waianaes. Where in the northern Waianaes, there are actually two populations that are being protected in these kipuka, in Pohole and Makaleha. And these kipuka are actually at higher elevations due to the northern Waianaes being taller than the southern Waianaes. With that in mind, a couple of years ago, CEP had proposed conservation introductions of concavospira into these kipuka in the northern Waianaes. And that's where my study picks up. So as land managers and as species managers, CEP needs to know if their actions are worthwhile and if they're successful. And with any translocation, you're always looking for survival and reproduction of translocated individuals. With Kahuli, it's a bit problematic in terms of keeping with an adaptive management timeframe. Kahuli can live upwards of 20 years, 20 minutes, 20 years, and their birth rate is really slow. It's 1 to 6 offspring per year, and they're slow to sexual maturity. It takes 5 years before Kahuli is able to give birth. So with this in mind, we want to think about more responsive monitoring regimes. We'll still keep track of survival and reproduction, but I suggest in my research that we start to look at movement behavior, so home range establishment in particular. If we think about as I think about and discuss with the CEP program and other conservation partners, the many translocations that have happened 10 years plus, they've noticed that Kahuli will travel away from the initial release area and eventually settle out within the kipukas. But if we're to graph that as just a general graph here, distance traveled away from the release site, you'll see or we predict that there'd be a period of wandering where travel away is marked by large distances early on. And as the Kahuli start to settle and exhibit site fidelity, returning to the same place, this curve begins to flatten out. And marking the home range establishment once it reaches an asymptote. So that's kind of a visual representation of the hypothesis that I came up with for our study, where lab-reared kahuli will establish a home range outside of their historic range. The objective of my study was to analyze post-release dispersal of Concavospira using home range establishment as an indicator, and also develop a viable post-release method of monitoring for SEP to use in the future. So what did it look like? So again, these are pictures of the different kipuka. You can see the fence structures that's designed to keep the 3 predators out. We transported 70 Concavospira in total. 35 were placed at Pahole and 35 were placed at Makaleha. The release sites were centrally located in each kipuka, and the cages were then opened for the kahuli to then disperse on their own at night. And this is me setting up an infrared camera to try and capture some of that dispersal. Once released, we return to these sites weekly for exhaustive surveys of the entire exclosure. Excuse me, kipuka. Exclosure kipuka is interchangeable. We're taking down a slew of different data, location data, taking photos of snails encountered 2 meters and below in the canopy. The photographs were then used in capture marker capture studies. In the capture marker capture study. And that's where things kind of came to a halt in terms of things rolling along. The photo identification software that we used took advantage of the unique markings on the kahuli shell as a way to identify individuals and then afterwards recreate their individual dispersal patterns over the 6 months. However, the new program that was created specifically for snails needed a lot of massaging, or maybe I just wasn't reading the instructions very well. But we're still working through all the photographs, and the goal is to get through them so that we can reconstruct individual dispersal patterns. Moving on, we looked at dispersal as averaging them through weeks or by weeks. At Pahole, just quick summary, they were released in March and post-monitoring extended all the way to August of last year. At Makaleha, the cohort was released in July and the monitoring was extended all the way till January. The discrepancy in release dates was due to collaboration between us and partner programs, making sure that everyone was okay with what was happening on site and what would need to happen in the future between monitorings and releases. So skip down to the small table at the bottom. We see that the maximum dispersal at Pahole was measured to be 14 meters, whereas at Makaleha it was about 8.5 meters. The minimum dispersal from the release point for Pahole was a little over 1 meter and barely less than half a meter at Makaleha. So this kind of gives an indication that there's major differences between the sites. We can move on to the next slide, and it shows the average distance by week graphed over the entirety of the study. The blue is the distance measured at Pahole, and the red is the distance measured at Makaleha. And we kind of do see a little bit of an asymptote forming for the Pahole dispersal. But I do caution that this is averaging across groups. We don't have individual identifications yet. So this is more or less just for general analyses. And then at Makaleha, we see that they're still kind of expanding and kind of wandering around. To get a little bit more into that, kind of go into the differences between the two sites. So here you see on the left Pohole and on the right Makaleha. Each square is a 4x4 meter quadrant that we use to geolocate the snails within the kipuka. Just pay attention to the orange dots. Those are Concavospira, and these are raw location data from the last two surveys at each site, just to show the spread over the 6 months. The original release point is indicated by the red X, and you can see kind of the differences in the two different sites. At Pohole, the kipuka was built around resident Mustelina that have been there since their ancestors colonized that area. So there's networks of snail slime all over the place that have been there like forever. And the Concavospira dropped right in the middle of that network. Whereas at Makaleha, the story of that kipuka is it was built in an area that hadn't seen kahuli for at least 5 years. And the Mustelina that were released in there about 2 or 3 years ago by the Army Natural Resources Program were released in the northwest corner and have since begun to spread out from there. When we had released our Concavospira into the site, we had chosen the central location because the outplants that the NRP has been putting in there have grown up to a decent amount or a decent size for us to be comfortable to release them in the center. But yeah, you can see a major difference between the interactions of the two species. So far, my study has been a part of two Concavospira populations outside of their historic range. Now the Concavospira inceps rearing lab have a place to go after 7 long years. We do have now a codex photo identification database to use for both release sites, and I have created a Snail Codex user guide to help people who are more visual learners rather than reading instructions and manuals. And I end with a face of pure joy. This is a photo of the first-born Concavospira in Makaleha. So somebody lied about the Concavospira all being subadults. But yeah. All right, take questions now.
Thank you.
Hello. A wonderful job. My question is, you had the releases at the different kipukas at different times of the year. Based on the data that you showed, that dispersal data, it doesn't look like maybe time of the year was a driving factor, but do you guys think that if you had released them at the same time, would you have seen something similar or different?
It's hard to say. We did have reservations about that difference, especially since the Makaleha release was during the summer. But the way the weather's been these past like 5 years, there's been really wet summers. Both sites we were actually shut out for multiple weeks in a row. One was because of thunderstorms predicted in the area, and another was for windstorms that were happening in the areas. So it's hard to tell, especially with climate change and just the weather being unpredictable nowadays.
Okay, that makes sense. Thank you.
I think I asked the same question when you presented. I'm like, having flashback, but just curious about, I know West Makaleha one's relatively new, like, are they, 2 questions, I guess, it's like, what's the age difference? And so what is the kind of canopy height difference? And I guess my question about Pohole, is it done the same way where they kind of like nuke the zone to get all the Eglantine out and then planted? Or did they leave canopy trees?
Yeah, so at Makaleha, it's like it was built during COVID, I believe. So it's less than 5 years old. But it was a site chosen because there's mature canopy trees, mainly bohea. There's lolu in there. But yes, to ensure that the area is free of predators, they did have to like scour the understory. At Pohole, we've gone through a couple of phases of scouring the understory just because we have detected predators there in the past. But we've developed methods that allow for like ferns, like palapalai and stuff to bounce back quicker after we're done. Yeah. Does that answer your question?
Yeah, I was just curious if the canopy structure was, like, how different it was. Like, thinking, like,
yeah.
that might have just explained clustering and stuff.
So we're gonna get into like veg surveys during the summer. But in general terms, at Makaleha, it's ohia canopy, about 15, 20 feet tall, and not much understory to connect. So they have to climb up the trunks of the trees to get up there. At Pohole, it's much more dense. It's mainly koa and Kupaʻa kepau, coides, I believe nowadays. But yeah, so it's the canopy is vastly different.
One quick question online.
Yeah, we have one quick online question. I don't know if that's a quick question, but I'll do your best.
Yeah.
From Dr. Vaughn. Amazing presentation, Kupaʻa. Could you talk a little about what it is like to work on this brink of extinction? And as more and more of our people will be, what do you recommend for younger ones coming into this work to sustain yourself and the species you care for?
Good question.
You have 30 seconds.
Okay, so I got into this work, not Kahului specifically, but with the mindset that I wanted to be outdoors and working in the environment in Hawaii. And it just so happens that Kahului was the place that needed me. Advice to younger professionals. Find some place or something that you believe in beyond just the paycheck. And that'll get you through the hard days. Yeah, I really love my team and the people that I work with, and that's more than enough to get me over the hump.
Good advice. Thank you.
And thank you to Kupaʻa's boss for being here today, and so much of his team for showing up and for making it possible for him to
You're on
do
camera,
this
yeah?
degree program as well while maintaining his work.
Which one is this?
Oh.
Yeah. Okay. All right. Let's go back to.
Yes.
Oh.
Yeah.
What is that? Oh, I think. Click on here.
Okay. Right. Good. All right. So Oli is our next presenter.
Thank you. Aloha everyone, good afternoon. My name is Olivia Carbi, and today I will be talking about my capstone titled Nurturing Leaders, a Holistic and Trauma-Informed Curriculum and Evaluation of the Partnerships for Pu'uloa Summer Internship Program. I'd like to thank my capstone panel, Travis Idol, Leah Bremer, and Kamuela Enos for their unconditional support throughout this project. Before diving in, I'd also like to formally thank OIKI, WRRC, NREM, UH-ERO, and Malama Pu'uloa for their support as well. This project was made possible because of a congressional earmark that was awarded to these organizations to develop a project based in biocultural restoration in Ewa Moku. So the goal was to not only care for the aina of this moku, but to also nurture the future leaders and stewards of this area. So from this came the Partnerships for Pu'uloa Summer Internship Program. I was one of two main graduate students tasked with developing the curriculum alongside Jade Rhodes. And I'd like to take a moment to thank Jade and Kari, who are seated here in the front row next to me. This project would not have been made possible without all of their hard work and dedication to this project. So this initiative provided undergraduate students within the UH system an opportunity to learn, grow, and connect with both Aina and the community of Pu'uloa, otherwise known as Pearl Harbor. Our goal was to equip students with the tools in biocultural restoration, research, GIS, network building, and more, all while allowing them the space to see themselves as potential leaders in the future. Our curriculum and experience as a whole really integrated aspects of academia while keeping in mind the social and cultural context in which the learning was taking place, as well as incorporating some spiritual elements, all while focusing on Native Hawaiian knowledge, culture, and protocol as the center. So the two main frameworks that went into developing this curriculum are the holistic teaching approach and the trauma-informed teaching approach. So the holistic approach aims at making learning a process of self-improvement while really focusing on the self and recognizing the social context in which the teaching and learning interaction takes place. And it really recognizes the need of the individual learners along the way. So one of the things that's central to this framework is moving away from a teacher-centered learning structure to a student-centered learning structure. And we did this by giving the students an opportunity to collaborate in the structure of the program, as well as finding ways for them to connect personally to the material that we were teaching. Under this framework, we emphasize participatory and experiential learning approaches, which involved hands-on activities, student-led activities, field trips, collaborative work with other organizations, and immersions into Aina work. A big part of this was also adapting our teaching strategies to the individual needs and skills of the students, because we really acknowledge that they all came with their own unique sets of gifts and weaknesses that they might want to work on with us. Our second framework was a trauma-informed teaching approach. This was very important to us because we acknowledge that the students that were participating in our program can come with different levels and types of trauma, especially here in Hawaii, where we can see this manifest in the form of generational trauma stemming from colonization, also imposed stereotypes in educational settings, and also varying types of socio and economic hardships that we can see today. So this framework really aims at addressing this trauma that can affect education by creating safe spaces and adopting flexible learning structures. Some of the ways in which we tried to do this were maintaining open and honest communication with our students, trying to find ways to constantly support them along the way, and also being very flexible with our deadlines because we acknowledge that the students may have other responsibilities that take precedence over our internship. We also wove in mindfulness and self-care practices throughout the program through the incorporation of guided meditations and art time at the end of Aina workdays to really focus on building relationships with the team and between student and facilitator. This framework also emphasizes the need for a culturally sensitive curriculum. So it was very important for us to collaborate with Native Hawaiian practitioners and stewards in the area so the students can learn directly from them and see what is being done in their community. So at this point, I'd like to differentiate between teaching methods and teaching approaches. The methods really pertain to the specific activities and actions that we took as facilitators to engage the students in the learning process, all while taking account their different abilities, needs, and interests. The teaching approach is more so the overarching wisdom that guides our methods. So in this case, that would be the holistic and trauma-informed frameworks that we used to develop the curriculum. So my specific objectives for my research project were to first co-develop the internship curriculum with Jade and OIKI and Malama Pu'uloa. And second was to facilitate the program and incorporate student feedback along the way. The third objective is to evaluate the perceived effectiveness of the teaching approach based on student feedback. So this is an ongoing project. I have completed the curriculum and facilitated the pilot program, but we will be doing a second iteration of the program this upcoming summer, which I will also be facilitating. So to make the evaluation process a little bit more rich and gain more feedback from the students, I will be interviewing the pilot cohort as well as the cohort of this upcoming summer. And this will include some one-on-one interviews with the students from both cohorts. And then after that, I will analyze the interviews to see what the outcomes of the teaching approaches were on student learning experiences, and also explore any potential synergies or intersections between the two teaching approaches to see if they're working together or if there's some potential friction between the two that we might not be aware of. So to dive into the first two objectives, I want to share a brief overview of the pilot program. This was an 8-week internship program spanning from June to July. The first month was made up of independent and online learning resources, and the second month was a hybrid mix of online, like virtual sessions on Zoom, and in-person Aina work days. The pilot cohort consisted of 6 undergraduate students that were in UH West Oahu or Leeward Community College, and we offered a stipend and tuition support for the students that participated in our program. At the end of the program, the students had to present their independent research projects, which were grounded in biocultural restoration in Pu'uloa, and blended different aspects of storytelling and data visualization through the use of ArcGIS Story Map. So our community partner for this project was Malama Pu'uloa, and our host site was the Hui Alaloa site by Pearl Harbor Historic Trail. So at this location, Malama Pu'uloa is creating a food corridor where the community can engage with the space and build relationships with the space as well. And feel free to pick any food or medicinal plants that we are growing in this location. So here's where we really grounded and honed into the different elements of biocultural restoration and what that could look like in Pu'uloa. So as I said before, the student-centered learning, that framework comes from the holistic teaching framework, where the students have the opportunity to engage in the structure of the program and engaging them in the decision-making process as well. So this image here was taken at Camp Alehua at one of our orientation days, where we asked the students to give us feedback on what their preferred learning styles were, as well as what their expectations of us as a Kumu team were, so we can make sure to honor that as the project went on. This picture over here is one of the student-led activities that we hosted at the Hui Alaloa site called Learn a Plant, Teach a Plant. And here the students were tasked to learn about one of the plants at the site and teach the rest of the class what they had learned about those species. And this picture over here was taken at Malama Learning Center, where the students had the opportunity to take some plant clippings home. This was a special day for one of our students that got to take home some crown flower. She's very passionate about making lei, and there was no crown flower in her community. So it was very special for her to be able to take back some of those clippings to share with her family back home. A big element of this also was being fully transparent with the students and letting them know that this was a pilot program and we were learning alongside with them, and giving them the opportunity to share their feedback with us to adapt the program as we go to make it best suited for them was very important. So next, collaborating and having guest speakers work with our students was also a key element of our program. We got to work with Malama Learning Center on a couple of occasions, which was very special for the students to see the work that is being done there. We also incorporated guest speakers into our virtual learning days to give students the opportunity to talk story with other practitioners and other people doing Aina work across the island. And we also even had one of our cohort members, Alyssandra Rousseve, speak to our students about her research and also her journey through graduate school. So the students can kind of start imagining if that could be a pathway for them, and also seeing that there's unconventional ways to enter grad school. There's not a one-size-fits-all. We really wanted to emphasize that. CreateX at UH West Oahu was one of our major hubs where we were able to blend in the elements of storytelling and data visualization. This is a data visualization lab that blends in modern technology with Native Hawaiian knowledge and ways of knowing. And it was created by Kari Noe, who also operates this space. And Kari was very central to helping the students develop their final projects, which we were able to do here at the CreateX lab. So finally, the students were able to share what they have been working on with their families and their kumu and anybody else that helped participate in the program through this ho'ike, where they were able to share not only what they were working on, but also provide a synthesis of what they had learned that helped them lead to their self-actualization and also further the understanding of the concept of Aina Mamona in their community and how we can all fit into that goal. I wanted to touch base on this picture here in the middle. This was a very special moment for me, where I learned how to make lei for the first time with some of the students. The same student that I showed before that took some crown flower back home led this lei making session. And it was very special for me to get to connect with her in that way and learn about a practice that she holds very close to her heart. So moving on to the evaluation portion of my project, this is a 4-pronged approach that starts with weekly check-ins as a form of formative evaluation, meaning it's ongoing throughout the program. Then I will be doing a summative evaluation at the end of the program, where I will be conducting semi-structured interviews with each of the students. This will consist of one-on-one interviews with any consenting student from both cohorts. There will be an option to do group interviews if students feel more comfortable coming together instead of doing one-on-one. And of course, there's always the option of in-person and Zoom, depending on student preference. I have just received IRB approval to begin the interview process in May, so I'm very excited to move on with that. After the interviews, I will be doing a thematic analysis, having a mix of inductive and deductive coding, where I will have a set of predefined themes, but also be open to any emergent themes that come up in the coding process. After the thematic analysis, I will be using cross-analysis, which is also known as cross-case analysis, to compare any of the themes that come up between the two different approaches and see how they might be working together, or if themes come up that are completely different from one another. And I'll be doing this using the Max QDA software for coding. Finally, I will be addressing data accuracy through member checking, where I will, with, of course, student consent, send them back their transcripts from the interviews so they can look through them, giving them the chance to change or omit anything from their transcripts before I consider it data. And then I will also offer to send back the themes that I come up with to see if it accurately reflects their sentiments from the interviews. So part of the evaluation process was developing evaluation tools. And these are some snapshots of the weekly check-ins that we created for the program in the form of Google Forms surveys. Here we were asking them for feedback on the Kumu team, anything that we were doing as facilitators, but also to reflect any personal self-reflections from the week that we should be aware of. Survey responses will only be included as data in my project with consent from the students at the time of the interview process. I also created a 12-question interview guide for the interviews under the guidance of Kumu Konya Freitas, who she recommended that I create this interview question tracker to stay grounded in the objective of the interview as well as the intention of each question. It's important to note that I'm not asking any questions that directly pertain to the teaching approaches, more so for the students to elaborate on their experiences and perspectives on the methods. And then on the back end, I will code accordingly to how the teaching methods pertain to each approach. So some limitations that I expect to find as I keep working on this is that the first cohort may have trouble recalling details from the pilot program when I interview them in May. So to address this, I'm prepared to provide examples or images to refresh their memory on what we did together last summer. And there's also the potential for students to withhold feedback during the interviews because they might just want to tell me what they think I want to hear. But I will reassure them that for the purpose of these interviews, it's just to improve the program as we go forward, and that their feedback is very valuable to us. And I will do my best to create a safe and comfortable atmosphere for them to feel comfortable sharing their opinions. Outputs of my project include the internship curriculum itself and an organized Google folder with all the supporting material for OIKI to use in the long term. And of course, the formative and summative evaluation tools that I created for the evaluation process. And I'll be providing OIKI with the recommendations report once I am done analyzing all the interviews so they can have it all neatly packaged for future reference. So to conclude my presentation, through this project, I helped create a practice that holds self-actualization and the restoration of Aina as shared values, and organized everything in a way that OIKI can use and reapply in the future. Through the evaluation tools that I created, I hope that we can better understand the students' perspectives with the teaching approaches and see how we can improve that moving forward. And of course, OIKI will be able to share the results of this project with any stakeholders for future funding. Mahalo, any questions?
Okay, yeah, so we've got a couple minutes for questions, so.
Thanks for that great talk. I'm excited to learn from the results of all your evaluation tools, but I was wondering, how were the students recruited? Like, what types of students were you looking for? Were they specific major or background? Or
So we were mainly focusing on students that have some sort of personal tie to Ewamoku, whether they live there or study there or have family there. That was like the main priority, but really we were open to anybody that wanted to learn more about biocultural restoration in this area. And mainly for like kind of recruitment, we created flyers, posted them around the different campuses, and also shared them with specific faculty that we thought could have students that would be interested in this program.
Online questions?
Yeah, we have an online question. Sorry, they're coming in fast and furious. Okay, so really important work, Olivia, and clearly presented. What do you think you might find in your interviews as far as impacts of your program on the students and on community?
That's a great question. So we did, oh, yeah, it's so awkward talking to the screen. So we did receive feedback along the way through the Google surveys that reflected the students were very excited and want to see more of the guest speakers and working with other organizations. So I expect that maybe the interviews can reflect more on their experiences working with other Native Hawaiians in the space. I think in terms of overarching impact with the community, it's very helpful to create this network where students can connect with other people working in this area to create pathways for potential career paths or collaboration in the future. So I think, creating these spaces where students feel comfortable learning and growing with other practitioners and in both academia and personal life is very important to build up capacity in this community.
I think we're done on time, but thank you so much.
Thank
Olivia,
you.
for the presentation. Thank you.
Shout out. I'm not sure if we have Malama Pu'uloa in the house, but I see a crew under Ethan Chang's name and lots of people online. So wonderful to have you all joining and supporting this work and helping to guide it. Mahalo.
Okay. Okay. Oh, yours is up as a Google Slides, yeah?
Yeah, and
Okay, I may have it already. Is that yours? Okay, all right, let me share this and then we'll get you set up. All right, so next speaker is Breeanne Fong. Welcome.
Aloha mai kako. My name is Breeanne or Bree Fong, and my capstone panel includes Dr. Clay Charnick, Dr. Travis Idol, and Dr. Taule. My project is entitled Malama Aina Ame Kamanapa, Engaging in Environmental Stewardship with Our Emotions in Hawaii. So the motivation for my project stems from the ongoing climate crisis, which effects have become more prevalent and visible, and this has triggered a mental health crisis, where people can't focus or are too stressed, anxious, or frustrated, and this interferes with their daily lives and functioning, making this an urgent issue that we need to address. These feelings of concern and anger have risen among youth, especially in climate vulnerable places like Hawaii, where there's increasing air pollution and rising sea levels. And this project was also personally motivated as I'm a haumana or student of Uhahumu Pohaku, which is the Hawaiian practice of dry rock wall masonry. And in doing so, I realized how beneficial this is for my well-being. So for some more background, ecological emotions or eco-emotions can simply describe how we feel about the environment, our relationship with the environment, and how we feel about issues like climate change. Major eco-emotions include eco-anxiety, which is when one is worried about the future state of the earth, while eco-anger expresses one's frustration that they have towards like the political and social systems that have caused and perpetuated ecological crises like climate change. And among ways to mitigate these negative eco-emotions, I looked into how environmental stewardship can enhance well-being and found that it's able to do so because it allows people to go outside and be in nature, connect with like-minded others, and with other people who share the same goal of wanting to restore the environment and give back. And so overall, these past research studies show how environmental stewardship has positive impacts on people's mental health. And then in Hawaii specifically, Malama Aina can be broadly interpreted as environmental stewardship. Malama can mean to take care of, and then Aina can mean land or that which feeds and sustains us. And so that can mean anything from the food that we eat to what may nourish us psychologically and emotionally. And so there have been several research studies on biocultural restoration and how Malama Aina enhances mental well-being, but none of them specifically look at eco-emotions. So for my project, I decided to look at this overarching research question of what is the nature of eco-emotions and how does it relate to Malama Aina engagement for people in Hawaii. And to answer this, I looked at the following objectives: exploring people's eco-emotions as they relate to climate change, and then investigating people's motivations for Malama Aina and its impacts on their emotions. And then I took a mixed methods approach and conducted semi-structured interviews or talk stories, as well as an online survey. And for the interview, I recruited participants at Malama Aina workdays, namely with groups like Protect and Preserve Hawaii, Waimanalo Limuhui, and 808 Cleanups, which are groups that I still continue to work with to this day. And then for the online survey, I distributed it via social media, emailing Aina groups and school groups, as well as word of mouth. For data collection, I auto-recorded all of the interview talk stories and then used Google Forms for the survey, which is still ongoing. And then for data analysis, I coded common themes for people's emotions, motivations, and benefits. And then I used Pasquale 2017's cultural framework to categorize people's motivations and benefits. And so for the results, for the interviews, there were a total of 21 interviewees. A majority of them are from or grew up in Hawaii, while a third identify as Native Hawaiian. And then the majority of people were ages 18 to 35 years old. And then for some more background on these participants, their frequency of Malama Aina engagement ranged from occasionally, which is less than monthly, to every day. But most participants engaged in Malama Aina work multiple times a week. And so these next few slides are going to be of word clouds on people's thoughts and feelings about Aina, environment, and climate change. And I separated Aina and environment because although some people view Aina and environment as the same, there are others who made a distinction in that Aina is something that's more deep and cultural. So I wanted to highlight the difference in emotions between the two. So as you can see with Aina, there's a lot more yellow words. The keys. So the words in yellow are going to be positive. The words in green are going to be neutral or more ambiguous. And then the words in blue are going to be negative, but more of the sad emotions. And the words in red are going to be negative, but more of like the angry negative emotions. So with Aina, there's a lot more yellow emotion showing that a lot of people had positive thoughts and feelings, with grateful and connected being the top two, which makes sense because engaging in Malama Aina work allows one to be more grounded and connect with the space that's around them, as well as other people doing the work in that space. And then in contrast, environment, there's some similar thoughts and feelings, but the main difference is that there are a lot more negative thoughts and feelings, and sad being the dominant one. For instance, one of the interviews expressed feeling sad as they witnessed changes in their natural environment and how over time, she became sad seeing how it's become cemented over with buildings and urban development in general. And so this feeling is what would be consistent with what is known as eco-grief, which is a feeling of loss that arises when one witnesses negative impacts on their environment. And so next we have climate change, which there's a lot more negativity certainly on climate change, which makes sense, with more of the angry negative emotions coming out. A lot of people express being frustrated with the people who are in power and control for not doing enough. Also, people were angry at others who don't know enough about environmental issues or who don't care. And then other people also expressed being anxious about the uncertainty of the future. And then I combined environment and climate change because a lot of the interviewees talked about the two together. And when talking about how they felt on the state of the environment, they mentioned climate change and vice versa. So I wanted a more comprehensive word cloud. And yeah, as you can see, sad, frustrated, angry, anxious being those top negative emotions, but they're also happy and hopeful, but more so lending to the fact that people were able to engage in Malama Aina work. So now for motivations and benefits, I also combine these two because a lot of the participants talked about them hands in hand. And I categorize them with these four main themes from Pascal's framework. So that's Ike, which is knowledge, Mana, spirituality, Palina Kanaka, social connections, and then Olamau, physical and mental well-being. And each of these themes had multiple sub-themes, and I'm gonna go through an example each of them. So for Ike, one of the sub-themes was diverse learning. One of the participants expressed, it's great to be a student consistently again and to be humbled in all the things that I don't know. To be humbled in how to learn and just shut up and listen. Ask questions, listen to people who are teaching, listen to Aina and the land. And so this shows how no matter how old you are or where you are, there's always an opportunity for you to learn something new. And I included this photo of kiloing at Koloko. Kilo is the practice of observation. So it's when you're able to just stand or sit still, engage in all of your five senses and observe your environmental surroundings. And so you're really able to learn from Aina and the space that you're in, as well as from other people who are kiloing when you share about your reflections and observations after. And then this idea of Ike and Kilo also tie into this next sub-theme of Mana, which is Ho'ailona, signs or bioindicators. One of the participants reflected, we dug out all the mud from the Punavai and we went back a month later and you could see how the water was flowing and then species coming back into the water, like the Opai Ulai came back and you can see fish coming back. And so this just shows how important it is to foster that connection with Aina because you become more attuned to that space, especially if you're taking care of this, going back and taking care of the same space, you're able to notice those environmental changes much faster and easier because of that connection that you have. And then with Palina Kanaka, Kokua Aku and Kokua Mai, presence of strong social ties and social networks. This was in response to the participants' favorite part of the Malama Aina workday. You meet somebody for the first time, you get to talk to them in a low pressure environment, then you might see them walking around and it's way easier to talk to them. You have that shared connection over Aina. And so this just shows how powerful engaging in Malama Aina work can be because you're able to form these relationships and then have them grow over time, especially when you go back to the same spaces with the same people. And I included this photo with Pico at Huilua. So Pico is like opening or like this introductory aloha circle where people get to say their name, where they're from, their intention for the day, and that serves as a conversation starter and a catalyst for starting these relationships and just strengthening Pilina overall. And then for Olamau, mental well-being was another common theme across all the interviewees. This was in response to how someone felt about the climate crisis and how Malama Aina helps mitigate those feelings. So he expressed, it's very easy to feel overwhelmed, and that's where being in community with people who care about these things and who are trying in their own little kipukas to do good work. That's the place to start. There's some learning and some of the feeling overwhelmed that gets more released in the work and somehow exhaled through. And so this just shows how beneficial Malama Aina can be for your mental health. You're able to de-stress and feel less overwhelmed. You're able to connect with others who may feel the same way and also share that same goal of wanting to restore Aina. And then for the survey, these are just some preliminary results based on the 45 respondents that I have right now. So about half of them volunteer or work for an environmental group once a week or more often, while the other half work or volunteer for an environmental group monthly. They have in the past or never at all. And then when they're asked, to what extent do you agree with this statement? Engaging in environmental stewardship helps me cope with negative emotions about the environment. Most of them said yes, absolutely, or somewhat. So it kind of shows that no matter how frequent they engaged in environmental stewardship, they found it to be beneficial in helping them mitigate those negative eco emotions. And so for limitations, one of them being sample size, mostly for the survey, which is still ongoing. And then also the population being biased in that these people or these participants were already Ono for this work, so they likely participate in Malama Aina work regularly, or they had already shown some interest in doing so. And then at least half of the interviews I had a personal connection with, but I thought this was important because it allowed them to feel more comfortable and dive deeper into talking about their emotions, especially since communicating about emotions isn't the easiest, especially with people you don't know. And so having that previously established trust, rapport, and connection with others, I felt was very beneficial and almost necessary for my project. And then also there's a lack of standard and just the general subjectivity and complexity of emotions. So I didn't really use like a formal diagnostic or psychological test to say that this person has ego grief or ego anxiety. I kind of just wanted to show that their feelings and thoughts are consistent with what is described on in previous literature on ego emotions. So in conclusion, at least for the interviewees, their main negative emotions included sad, frustrated, and anxious, while positive emotions were hopeful, happy, and connected, which makes sense because majority of participants had reflected on how Malama Aina has had a positive impact on their quality of life. And that's more or less to do with the connectedness, whether that means they're allowed to connect with the Aina or people that were on Aina as well. And then Malama Aina is a coping mechanism for negative ego emotions or negative emotions in general, and essentially just shows how interconnected our well-being is with the well-being of the earth and the Aina. And so when Aina thrives, we can also thrive. So mahalo nui kako. Thank you all for listening. Especially thank you to the Aina-based groups who continue doing the Malama Aina work, my capstone panel, all the project participants, and my ohana and hoa. And the survey is still ongoing if anyone wants to take it.
Time for questions. Chance to reflect a little bit, take a breath.
Yes, Rachel. Thanks, Bree. That was great. I was thinking about the different organizations that you recruited your interviewees from, and I'm not super familiar with each one of them in particular, but I have a sense that they may engage a little bit differently, or their profiles and the way that they
Oh yeah, for
feel
sure.
about their work is a little bit different. So I was wondering if you maybe learned or saw any differences in the respondents of those three groups at all, just based on the way that they.
That's a good question. I don't think I really looked at like those differences specifically, but a lot of, or like the majority, like how I said, like the majority of people I had like personal connections with, everyone more or less has like volunteered with those, like the same group. So I also like made sure that it was either 808 cleanups or protect and preserve. That's how I recruited, was from one of them. Yeah.
We don't have any questions coming from online yet, but a lot of congratulations. So continue to take them.
Yeah, I have a question. I know we talked about this so much, but like difference between motivation and benefits and like how.
Yeah.
I guess like, do you think that, I mean, do you have any other ideas about whether you could try to separate them out? Or alternatively, do you really need to?
I feel like they go so hand in hand, but I think it's possible to separate them. It's just that the themes that you would see for both are going to be very overlapping. Yeah.
I have some thoughts.
So we do have an online question.
We got time. Yeah, we got time. Go ahead.
Okay.
Yeah.
So from Dr. Vaughn, Bree, really profound work, effective ways of sharing findings and beautiful quotes help us all to think about often unseen importance of Aina work. Did you learn anything of factors that might support or lessen the impacts of this kind of work on those who do it, and how those factors could be more supported to enhance impact?
Did you mean the, wait?
I think, and Mihana, you can unmute if you want to clarify, but I think what she's saying is that, you know, when we do this work, like watching Kohuli decline in places or whatever, it can impact us. But is there something about that work that helps to lessen the impact of the potentially negative impacts?
And
Am I
also,
getting that
Breeanne, you found so many positives from doing this sort of work, but you know,
Oh,
the same, every group isn't the same. What helps to make that really especially powerful and to support impact for those who do the work?
wait, sorry, impact meaning like emotional, mental, or like impact in general? Like
Meaning
the
the
environment.
positive things you talk about, like emotional health, connection to others, feeling replenished. What are some of the ways that these groups can really make sure to foster that in the experience of those who work with them?
Oh yeah, so actually part of my outputs, I'm going to like make not like recommendations or just kind of show like a summary of like what I found from like these groups. So it can like it will detail like what like stood out about maybe their particular workday or what they did that people find themselves coming back for, or like what's been helpful for them. But yeah, sorry, I didn't mention that as one of my outputs.
Yeah. Good time for one more question.
I was just curious, did you think to categorize the responses according to the age groups and see how?
No, I haven't, but that's a good. I'm still like analyzing, especially with the survey. So yeah, that's definitely a possibility. Thank you.
Thank you. Appreciate your question.
There's at least one more question that just
Oh,
came
okay.
online, if you can address it.
So Kat, you're our next presenter, yes?
Can I? Thank you.
Yes, that's me.
Is she able to share her screen? Sorry, yeah, Kat's, yeah. Okay, so I think you can share your screen, Kat. And then hopefully we'll see it up here.
Okay. Me. Right. Can you all see it?
We can see it. Great. Okay, take it away.
And you all can hear me clearly too, correct?
Yep.
Yes.
Yes.
She wants
Okay. All right, awesome. Okay. Aloha. Hello, everybody. My name is Katherine, and I'm going to be presenting my project to you today. Titled Invasive Vegetation Management, an Overview of 2 Fire Risk Species. And first off, I would like to thank my capstone panel, Dr. Clay Trowanick, Stacy. Sorry?
Go ahead, just to make sure I'm not getting feedback from our Tatum. Okay, go ahead. Sorry, Kat, go ahead.
Oh, sorry, no worries. Stacy Turgoy and Dr. Travis Idle. I'd also like to extend my thanks to the National Park Service, especially the fire management team there, for providing me the information and guidance to complete my project. So Hawaii has been experiencing an increase in fire occurrences, as well as several places across the Pacific. Multiple studies indicate that invasive species have influenced this increase, including invasive grasses. The Hawaii Invasive Species Council currently does not have a regulated invasive species list. However, the numbers are believed to be around the thousands, in the thousands. Hawaii places great emphasis on its native biodiversity, which is very important to Hawaiian culture. The islands currently host around 1,400 native plant species, and around 90% of these are endemic to the islands. And so this makes it, with this being said, this makes it even more important to protect these native ecosystems, while also understanding better methods to manage the invasives effectively. So I focused my study in Hawaii Volcanoes National Park, looking specifically at their invasive management program, working with 2 species of concern relating to fire. So the two plants that I looked at were the fire tree and the fountain grass. You can see them pictured there from left to right. So both plants have multiple studies that provide evidence relating to them promoting fire occurrences. The Marilla fire has been introduced to countries such as Australia, New Zealand, and even the United States. However, it's only considered a noxious weed here in Hawaii. Its native region is located in Portugal and the Canary Islands over in Europe. And my second plant is the fountain grass, which is a perennial grass native to Africa. It's currently found in several places in the United States, including California, Arizona, and Nevada, where it is identified as an invasive species. In Hawaii, it is present on Oahu, Kauai, Lanai, and Hawaii Island. So in general, invasive species alter fuel availability and abundance properties in an ecosystem. When there are higher fuel loads in a certain area, there is a larger chance of impacting fire behavior. There's also been a linked trend of the increase in the dispersion of invasive species and fire incidence and severity. In Hawaii, locally, this trend has also been observed with increasing overall burned areas, as well as increasing severity of fires. So my objectives for my study were to perform a literature analysis to identify those literature gaps, specifically looking at my two invasive species, the fire and the fountain grass. And then also I also organize a data set to contain only the fire and the fountain grass data, which I received from the park, from their invasive species management database. And I pulled out the specific management units concerning the two species. And overall, I wanted to provide evidence concerning invasive management and also provide the park an analysis tool for future use. And so how I did this was first I gathered my literature together over a variety of topics, including invasive species management, both locally and globally, the grass fire cycle, fire and fountain grass in Hawaii, and all of my sources were from online databases. And so my next step going into the data extraction and organization, I took the database directly from the park and I inserted it into Microsoft Access, where I was able to extract the chosen variables to eventually transfer over to Excel for the organization portion. And the variables that me and my collaborators chose would provide the best picture of the management was the total worker hours, the total individual plants treated, the herbicide used in the treatments, as well as the total area of each of the management units. And lastly, I would insert the extracted information into Microsoft Excel, which to look at just the management units and divide the information to per each year and to have the totals of the variables chosen. So for my results portion, For my literature review, I focused on 3 important topics involving grassy and woody species invasions, as well as the ecological impacts of both phaya and fountain grass. When looking at both grasses and woody plants relating to fire, an important process to know is the grass fire cycle. And so in the first paper by Fisco et al., the cycle, it's mentioned that the cycle is initiated by easily ignited grasses that carry fires across large areas into the woodlands. The invasive grasses experience quick recoveries post-fire, which ends up adding more fine fuel to an ecosystem, which ends up heightening the potential fire risk, which is mentioned in the second paper by Kearns et al. On the other hand, a study by J.K. Brown highlights in general how woody species increase the amount of thick coarse fuel loads, which is shown to increase fire intensity. Looking at the phaya specifically, when it invades an ecosystem, it disperses into thick groups or thickets that will tend to grow fairly close together. And with their flammable foliage and quick growth rate, they pose a significant threat when it comes to fire, as discussed by Lo et al. Additionally, phaya can alter nutrients in the soil it occupies. The tree is a nitrogen-fixing one, which allows it to occupy soils in areas that contain less nutrients. And this is according to the paper listed there by Vitusik et al. And also, like phaya, the fountain grass can spread onto bare lava flows, which have been problematic for management staff as well. This is talked about in the Rowe et al. Paper. And additionally, in a study done in Hawaii by Litton et al., the presence of invasive grasses increases the overall amount of carbon in the soil. And so when this carbon accumulates and increases, it also increases the biomass and debris from the grasses, linking this to increase fire risk as well. And so for my data table, as you can see here, I've attached just a part of my finalized data table that I created after I was finished with the organizing. You can see on the left side in the first column, I have the management unit name listed. And then in the second column, you can see the variables listed that were chosen for analysis. And so if you look across the table, you can see a span of over 20 years of data and all of the totals listed down below hand, as well as the last year that unit experienced the treatment. Overall, there were a total of 39 units that I used in my study that had an enough amount of data that could be used for analysis. And also wanted to note, if you look below, the total the total amounts of the variables treated, you can also see there's 3 rows of values and these are the numbers of the variables listed above. So they were all divided by the total area of row, which would also provide some information for analysis as well. So as you see this now, throughout the process of organizing the data, I also ran into some issues. We did have a problem earlier on, looking at, so all of this information, each of these treatments were linked together from an event ID, which identified each of the times that a treatment was performed. And several of these contained duplicate values. So a lot of those were listed multiple times. And so we had to delete those and figure it out. And so with all of this information in such a large data set, it was really hard to draw connections between all the information and the variables. Another thing to note is you can see all of the zeros that are spread across the table. So these were actually manually filled in by myself because there are several values just missing in all of the years. But the reason that we filled it in was for analysis purposes to have a value there. But basically what this is just that there were no treatments done in that year at all. And so with so many of the years missing the data, it did make it more difficult, or will make it more difficult to draw linear conclusions. And also another thing to consider is that all of these management units are spread across a very large area. And so they are located in different ecological regions, which experience different environmental conditions. And so with them being in these conditions, they receive different treatment cycles, sometimes more frequently or less frequently. And these areas span from drier environments like such as dry ohia woodland to more wetter environments, including rainforest. So I also attached this here. This is just, this is also part of my results. This is just the totals throughout the 20 years that I looked at of all of the management units altogether. So you can see the variables listed above, and the years are now listed on the left side in the first column. But I made this table also just for if the park wanted to see the overall their treatments over time altogether. So after looking at the literature and the data, the emphasis on studying invasive species and their impacts on native ecosystems is significant to bettering environmental resilience. I hope that my results can provide a tool for land managers to utilize to improve future invasive management. I also hope that the data table will provide a concise management history for phaia and fountain grass in the units for future analysis, as well as making connections relating to the current state of the areas. In the future, it would be interesting to see just fountain and firegrass, to see just the progress of the invasive species management over time as it continues. It would also be interesting to see to expand the research to the other invasive species that the park has been monitoring as well. Additionally, it is very important to encourage the continuation of the management monitoring and collecting these records. This way that there will be information available to be used in the new updated systems and in organized systems. So thank you all for listening today, and if you have any questions, please let me know.
We have time for one or two questions. Thanks, Kat. Yeah.
On the data table that you showed where you were filling in the zeros, of the 3 sites, I think it was like Idaho North on the top had a lot of treatments in like the early 2000s, and then there's been no treatments like recently. Are those like gaps in treatment because there's no like outbreaks at those sites anymore, or is that like a symptom of like capacity or lack of capacity to go out to those sites anymore? Or?
So actually, that specific unit, the Idaho one, was actually part of a subgroup, another group that was abandoned because some of the units, they just have so much vegetation and overgrowth that they actually it just wasn't efficient enough just to keep treating them. So that's why like the treatment is kind of inconsistent over the years.
Thank you.
Thank you.
All right. Any questions online?
No, there aren't any.
Okay. Well, through all the questions, thanks so much, Kat, for presentation, and we'll move on to the next presentation. Tatum, you are. Share screen and then hide this. Get that started. Hopefully that'll show correctly on the screen. There we go. Okay. So you guys seeing the presentation slide of this? Yeah, the right screen.
It's not.
Okay. Let's see. You go ahead and start it, and then we'll share. Seeing this.
Oh, and then share.
Yeah, see if you can share that part separately. Yeah, so. Getting. Okay, and then let's see if I can. See if we can share that. Is that it? Oh, was this the one? Which was this one or this one?
I think, yeah.
Okay, so what are you guys seeing now? Oh yeah, is that it?
We-
Okay. Okay. You good? All right. Thanks, Tatum. Go ahead.
Aloha, I'm Tatum or Kupaʻa Kauka, and the title of my presentation is Investigating Factors of Understaffing for Hawaii Natural Resource Management. And my panel members are Dr. Chan, Dr. Idle, and Espen Borsting. Oh, okay. Okay. So my motivation behind this project, I'll start with the biggest one, personal ties to this issue. Family members of mine, friends are really passionate about this kind of work, but I've noticed that a lot of them have had to leave over time, specifically my older brother, complaining in my ear constantly. So that was a really big motivation for this project. And, as I started to look into this issue, I firstly looked at the global scale, and I found that our whole world is currently very understaffed in this field. We're only meeting about 20% of the demand. And oftentimes the excessive shortages are leading to about half of organizations across the globe failing to operate, which means that a lot of agencies aren't meeting their goals and targets related to natural resource management. And, I'm pretty sure we're all aware that natural resources have such high social, economic, and cultural value, especially here in Hawaii. And so this problem for this field is not really understood and not really looked at. And so as I started to look at the issue more so at the scale here in Hawaii, again, we're seeing that understaffing across public and the private sectors. And same thing as the global scale, a lot of initiatives and goals of these agencies are not being met. They've been having to, expand the timeline, as we all know. And some of this public data that I found because of its easy access was even recently, just last year's budgets for some of our public agencies reveal that we're even having to further cut positions and projects. So the problem is still continuing. And so when I started to look at how other fields solve understaffing, or at least better understand it, right, in different areas, because it doesn't exist here yet, I found that perception-based research is often used. But when you look at environmental or natural resource related perception research, it's limited to environmental awareness, actions, sensitivity, and marketing. So I already stated it, but the knowledge gap of this project is that there's limited perception research for these occupations. So the primary objective of this project was to clearly define and understand the factors that are affecting this crisis within this field, specifically at the individual level. And this primary objective led me to create 3 smaller research questions. First being, how do people, both experienced and inexperienced, how do people for this field perceive those factors that are affecting this problem? Is the relationship between different demographic groups and those perceptions? And lastly, what areas of improvements can participants articulate? And so I didn't mention this yet, but a lot of the times perception research uses surveys, obviously getting participant feedback. And that was the whole goal of this project, was to amplify and highlight the voices from employees. Usually employee-related research will often only times survey employers, but this time we got feedback from employees. And so I partnered with Kupaʻa Hawaii. They are a nonprofit that has this really good network, what they call their natural resource sector partnership with agencies in this field across Hawaii, in the public, private, nonprofit sectors. And yeah, so we agreed that it would be a great idea to send my survey that I created alongside them to their partnership, again, which has access to a lot of different people. And then I also knew that I wanted to survey students, like I said, people who haven't necessarily got their feet on the ground, but are interested in this kind of work. And so I also sent my survey out to departments here at the University of Hawaii at Manoa, and specifically departments related to natural resources, environment, INA, whatever you may call it, but yeah, environmental. And so alongside my Kupu team and my panel members, we created an online anonymous survey through Google Forms, which ended up being 6 total sections with 20 questions, 18 of them being closed response and 2 were open-ended. And I just wanted to put this quick blurb about my data collection. So I did get IRB approval for the survey, but my dissemination was very experimental. Obviously, my first time conducting this sort of research, but what I generally did was contact my Kupu team and the UH departments that are relative to this kind of survey data. And after I initially contacted each individual, I would then send them this flyer asking for participants, as well as a recruitment script. And then if my request was approved, they sent it on to their appropriate emails. And so I did 3 different analyses for this project. First being descriptive statistics, summarizing the people in my, from the survey, as well as a multilinear regression to test and compare different values of the responses that I got. And lastly, a thematic analysis, which conceptualizes and helps to identify themes that participants talk about. And so my first result from the descriptive statistics, this is just a table of all of my responses from all of my participants, actually, split up by age, gender, years of college, intended major in this, either inside or outside of this field, as well as experience in the field. And just to note, I did get 132 responses, but after some thorough data cleaning, I used only 126 for the purpose of this project. And this was part of my approach, but I thought it was key to note before my results of the survey. A big part of before I even created the survey, I did some semi-formal interviews with employees across different sectors in Hawaii, specifically from DLNR, a couple of nonprofits on the Big Island, and a couple here on Oahu, but the Waianae side. Anyway, so what I did during those interviews was I had them help me, I guess, identify what they already think are some attributes that are affecting the workplace. And fortunately, through employment-related research, again, in other fields, those factors actually align. So the 8 in the middle are all the factors or job attributes that align across my interviews with people in the field, as well as literature. And so this model is adapted from one of my research articles that I used for this project, but it's basically trying to show that if the attributes in a job in the center are successfully implemented in a workplace, that'll improve job satisfaction and reduce turnover. And so going into more of my descriptive statistics, keeping those factors that I just showed in the model in mind for the rest of this presentation, one of the questions on the survey asked participants to rate each of those attributes. And through my statistics, I found that there were consistently 2 attributes that were always like the highest rated across all the people, no matter what demographic you come from. And that was having an adequate compensation, wages, and benefits, as well as having a positive and transparent work environment. And at the same time, on the other hand, there were also 2 attributes that were consistently ranked lowest, which included challenging or interesting job duties, as well as having recognition and awards in a job. And then onto my multilinear regression. A lot of numbers. I wasn't sure how to showcase this in a more visual way, but try to explain my best. So basically for my regression, I'm trying to ask the question, which demographic factors make a difference in perception? And so all of the green cells show that demographic group does feel differently about each of the attributes on the left. And all the green cells are highly significant. So clearly gender does play a role no matter what attribute you're looking at. And in this case, or my regression, all these numbers are saying specifically for gender that females are actually rating the attributes higher than males do. But if you look at age, there's only, age only plays a difference for one of those attributes, which is work location and hours flexibility. So older people are valuing this attribute higher than younger people. And the same thing for education. So the green cells are people with more education, value those things. Major, people who are in natural resources, major in college, value, for example, compensation higher. And lastly, for experience, that single green cell, people with experience in this field value personal and professional development more than people who are outside or don't have experience yet. And so going on to my thematic analyses, I did 2, but this first one, I asked participants to talk about any barriers or challenges that they've had to overcome to pursue college in this kind of field. And so there were 4 main themes that came out of all the responses. A lot of the responses actually touched on different or multiple themes. So anyway, the most common theme here was the education system itself. I translated every response into different barriers. So these are some of the top barriers from each theme. For education, that included the high cost of attendance, limited external funding, class availability, difficult coursework, and lack of mentorship. When you look at barriers for the field itself that people talked about, NRM stands for Natural Resource Management. Anyway, so some of those top barriers, people said that the industry as a whole is underfunded. There's a lack of the number of jobs and opportunities, and there's different gaps, whether that's between public and private pay, as well as research and policy, and political corruption was also talked about. And for positions themselves within this field, a lot of people talked or stated that the wages and salaries of these positions are low. The amount of qualifications for both education and experience are unreasonable. Labor is challenging, jobs are not flexible. And I also actually got surprised by this, but there was some gender discrimination that was talked about. And lastly, the external barriers that people talked about included Hawaii's high cost of living and the social acceptability of being in this field. And for my last analysis, this was for one of my last questions on the survey, which asked participants to talk about additional attributes outside of the one that I already surveyed on. So some of these attributes included, this is basically telling us what people want out of these jobs: passionate and meaningful work, collaborating specifically with Indigenous communities and practices, again, a livable wage, development, and culture. And so going backwards to my research questions, I just wanted to showcase and say again that these findings are pretty consistent with other employment-related research, as well as just simple conversations between some of the people in this room. And the hope is that a lot of this data can be taken back to employers and used in the marketing and structuring of jobs in the future, with a focus on some of those factors that were identified as most important, or having less of a focus on the factors that were rated least important. And some of these patterns and differences, even across demographic groups, can be used in a similar manner, specifically in recruitment phases. Lastly, what areas of improvements can people articulate? This one's pretty obvious, but people identified barriers in those 4 different themes. People also talked about what they want out of a job. What should the job be providing? And same thing, those trends can be used in marketing and recruitment for employers. Some limitations, the sample size, again, I got 132 responses, but for other employment research, in other fields, they can use about 1,000. So this is just a fraction of the workforce. The audience was kind of broad, so it's difficult to make really specific conclusions about people. I did have some survey in structure inconsistency in 2 portions. And then the biggest limitation is time. Due to the nature of this program, I wasn't able to analyze or report all my data that I gathered. But despite these limitations, again, right now, there's a lot of benefits from the study. I mean, it amplifies existing hearsay to each other, as well as occupational knowledge. And it provides empirical evidence towards these fields, more specifically, this is a repository perception data set. Yeah, and the benefit, thinking about people goes directly to decision makers, managers and staff, as well as education divisions. And the hope actually is to either continue the study alongside my Kupu team or give someone else the ability to replicate it while adjusting those limitations, which again, will hopefully in turn further improve in the very long run, understaffing in this field. And yeah, another kind of big goal was to overall enhance outreach into these jobs. I noticed that a lot of local kids growing up don't realize that this can be a job long-term. So that was, part of this project. And thank you to my panel, as well as my cohort and my Kupu team, and the departments that participated.
All right, we have time for a couple questions.
Tatum, wonderful presentation. Thank you so much. I have a question. You said that you started with a certain amount of surveys and then, for your actual project, you used fewer. And can you just speak to the process that you used, to kind of dwindle down your amount of surveys?
So my initial surveys were kind of, so again, I was trying to get perspective on, these were more people in power in some of the agencies across Hawaii. And so I wanted to get their perspective initially, what they think is creating this understaffing problem. And so all of their responses, right, helped formulate my actual questions for the survey, trying to understand different perceptions. I hope that answered it. Okay.
Any online questions? No. All right, got time for one more then.
Yeah, this isn't exactly related, but I feel like it's really like speaks to the other side of what you're, I mean, it's really cool work, first of all. But I was curious, you had this really kind of scary statistic at the beginning, the 20% capacity. And I was just thinking, if you had thought about how they measured that and what it might look like to figure that out for Hawaii.
I did. So the interesting thing, yeah, it's a statistic, right? And so they were looking at the ocean as well. I mean, obviously, the amount of people that can manage marine resources is a lot different to scale. Yeah, I haven't really thought about that statistic for Hawaii. I could see that in a sense, that same statistic kind of matching here, because we are obviously surrounded by water. Yeah.
Or just kind of hit like, it's like, whoa.
Yeah.
But it just also makes me think, how would you go about, like, what would it look like, right, if we had adequate?
Right.
But the funding, the thing that you're addressing is pretty cool because it's really the immediate need, I think. And we could talk later. I think we talked about this again when you,
Yeah.
but we found real similar results. We did this workshop at the
Right.
conservation conference and everyone was just like,
yeah,
low pay to idiots.
Yeah. All right, thank you. Thank you, Kayla.
Thank you.
Oh, yeah.
Is yours. Okay. Okay, let's do this. We wanna show it first. Sleepwalking.
Those two.
You want to go
Thank you.
Zoom.
While they're setting up, I just want to thank those who joined us online today. We've had over 75 online attendees who have joined at various points. So many of those represent the people who you all collaborated with, as well as your family members, friends, people showing up to support you. But I just want to thank those who joined online and those who made the long trek to campus to join us here, who have supported these students throughout their time in graduate school and are continuing to support them in their final presentation. So thank you.
All right. So Liz, floor is yours.
All right, thank you. Aloha mai kako, olis ko'u inoa. Hello, everyone. My name is Liz, and this evening I have the privilege of sharing my capstone research with you all, which involved monitoring aquatic species from Mauka to Makai in Halawa Stream here in the Mokupuni or island of Oahu. Before I begin, I'd like to give my warmest mahalo to my capstone panel, including my advisor, Dr. Yin-Fan Tseng, Dr. Tomoaki Mira, my third capstone panel member, and Dr. Travis Idle. All right. So the inspiration for this study is really drawn from the incident that happened back in November of 2021, known as the Red Hill Water Crisis. So here, the US Navy compromised an aquifer that supplies potable water to southern Oahu in the mokus of Kona and Ewa. So they inadvertently leaked 19,000 gallons of fuel into the surrounding environment at the Red Hill Bulk Fuel Storage Facility, which is shown in this image right here, right next to the South Halawa Stream. And really, this prompted damage control efforts to be made. And so in January of 2022, a collaboration between the US Navy, the Hawaii Department of Health and the US EPA initiated what is called the Red Hill Shaft Monitoring and Recovery Program. So in accordance with this plan, they would pump the aquifer at a rate of approximately 5 million gallons nearly every day, filter it through a granulated activated carbon system, and then discharge it directly into Halava Stream, which is shown right here on the right-hand side. So my capstone project is really looking at the impact this discharge has on Halava Stream. Furthering my motivation to study Halava Stream is the cultural significance of Kapukaki, which is really rooted in mo'olelo and stories and what these mo'olelo can teach us. So the Kea o Mele Mele of Mo'oinanea, for example, or the legend of Mo'oinanea, she is the revered matriarch of all mo'o and resource guardians or lizards. And what this Kea o Mele Mele speaks of the time when she summoned her family from their homeland, ordered them into a procession, starting from Wailua up in North Shore, all the way down through Kapukaki. And so this mo'o procession really teaches us that our waterways are connected. So Oahu has vast ecosystems across the island, and they're interconnected by surface water and groundwater. And so harmful occurrences that happen in one area may spread to all pathways. On the flip side, we have adaptive actions that may trigger expansive rejuvenation. And so just like the mo'o, those charged with managing and protecting our vai must investigate the disastrous circumstances that happened at Kapukaki, as well as the damage control procedures surrounding them. So there's scarce literature on the ecosystems of Hawaii's mixed streams. When I say mixed streams, I mean streams that are a combination of natural stream beds and concrete stream beds. And so of the literature that's available, Michael Keto in 2001 conducted a study assessing the biotic integrity of Halava Stream. What they found is that the hydrology of North Halava Stream is intermittent, meaning that it typically flows during heavy rainfall events or during the wet season. And their study was restricted to North Halava due to the fact that South Halava Stream, which is shown on the image on the bottom right, had little to no flow. And they found that the habitat was rated as poor and that the biotic integrity was rated as impaired. And this was mainly due to the fact that there was an absence of native species. Of the species they found, for macroinvertebrates, they found non-native fly and caddisflies, and then for fish, non-native rainbow guppy, green swordtail, and a Chinese catfish. So because little to no flow was observed in South Halava Stream and North Halava Stream is an intermittent stream, there's no documentation of how a continuous flow might impact these impaired mixed streams. So that really sets the stage for my study. So my study asked the question, how did continuous artificial increase in water flow impact Halava's ecosystem over the first 2 years of discharge? And specifically, I'm looking at benthic macroinvertebrates and fish and how the impact might have altered variations in their abundance, biodiversity, and community structure so that we can better understand what are the consequences of an altered flow pattern of Hawaii's intermittent, mixed, and impaired streams. So here's an aerial image of our study sites. We had a total of 7 sites. The GAC discharges noted in yellow, and our dark blue squares are freshwater sites not impacted by the discharge. The light blue squares are freshwater sites impacted by the discharge, and then the brackish water site is shown in purple. And then this next slide is really just showing you the physical characteristics of our sites. So we had natural stream beds, we had concrete and channelized stream beds. So diving into the approach now, so we did an ecological monitoring of Halava Stream, specifically looking at biotic factors. We conducted our surveys on a quarterly basis or 4 times a year, and we're looking at benthic macroinvertebrates and fish. So for benthic macroinvertebrates, we collected our samples by 2 main methods. So that's the rock scrubbing method shown in the top left there, and then the server sampler, which can get a flat substrate. We sent our samples off to aquatic biology associates, where a taxonomist identified the benthic macroinvertebrates, as well as providing us with a Shannon-Weiner diversity. The Shannon-Weiner diversity looks at species richness, so how many taxa are found, and then as well as species evenness, so how abundant across all of those taxa. Then we had a stream expert. He was able to go out to all of our sites and visually count how many fish were at each site, as well as identify them. And then group them into native and non-native fish, as well as providing a Hawaii Stream Index of Biological Integrity, which assesses each site over 5 different ecological parameters. So now diving into our results. So these are benthic results for sites that were not impacted by the discharge. So across the x-axis, we have the data of our survey. Across the y-axis, we have our benthic macroinvertebrate counts. Just note that each figure has a different scale. Couldn't really put them all into the same scale and visually see the changes that are happening. So what we're seeing are some temporal trends, some seasonality. A lot of the peak abundances across all of the taxa are being shown in the dry season. So that's that red area. In the blue area, that's the wet season. And what we're seeing also is that we have lower abundances in North Halava, so our natural stream sites relative to South Halava, which is our channelized site, and that the natural stream sites at North generally had a greater biodiversity in terms of how many taxa there was and the evenness that I talked about. And then South Halava at the channelized site, it really just had one high abundance of midges. Moving on to benthic results for sites that are impacted by the discharge. So overall, we're seeing higher abundances than the natural sites that weren't impacted by the discharge. Specifically, even immediately downstream of the discharge site at our USGS station, this had the highest relative abundance out of all the benthic macroinvertebrates. For our freshwater environments, caddisflies and midges were our most dominant taxa. And then at our brackish water site, midges and snails were our most predominant benthic macroinvertebrates. And then you actually see a notable shift from midges to snails in May of 2023. And then moving on to fish results. So these are sites that were not impacted by the discharge. All of the colors that you see in blue or a shade of blue, those are our native species. And what we're really seeing in these figures is that the non-native species dominate over the native species. We only saw less than 15 o'opu nakea over the 2 years that we studied. And then Mexican molly, so this fish was the most predominant fish in the freshwater habitat here at the natural sites, and is actually displaying some seasonality as well, with peak abundances in the dry season. And then of note, there was no fish at the SH up location. So now moving on to sites that are impacted by the discharge. So again, Mexican mollies being the most abundant fish that we're seeing. And then some seasonality trends both in SH above confluence as well as HA down confluence. Again, peaks being in the dry season. And then if we move to our brackish water site, which is shown in the purple there, the black chin tilapia were the most abundant fish in the brackish water. And then again, non-native species really dominating over the native species. So now we're looking at the Shannon-Weiner diversity. So each color corresponds to a different site. And our natural sites are red and orange. So we're seeing generally the greatest overall biodiversity at these natural sites, not impacted by the discharge, except for May of 2022. The lowest biodiversity was generally seen at Salt Lake Boulevard, which is shown in gray. And then generally speaking, our USGS station, it had lower biodiversity than sites not impacted by the discharge. Now looking at the HSIBI, so SH up shown in pink and Salt Lake Boulevard shown in gray. These had the lowest overall HSIBI levels. And NH up's really high level of 60. This was due to the presence of an oopu, and this oopu actually had really high reproductive capacity, one of the ecological parameters we looked at. And then of note, there was no HSIBI if there was no flow or no animals present. So moving on to outputs. So we provided stakeholder updates to our following stakeholders here, DAR, NAVFAC, the U.S. Fish and Wildlife Service, and the Commission of Water Resource Management. We provided them with result updates as they came available to us on a monthly basis. And then next month, we will present to our stakeholders with the 2-year final summary report. An additional output is that we now have a repository resource for all of the identified taxa that we found, as well as a quantification of their populations, as well as biological assessments of the HSIBI and the Shannon Wiener diversity. And then lastly, a standard benthic sampling protocol for Hawaii's mixed natural and channelized streams. So some limitations to our study. So one of them was that we did not conduct a pre-discharge benthic survey, so we weren't able to compare those results. And that was because they tacked on the benthic portion of the larger project after the discharge had already happened. So to try and rectify that, we compared our natural stream sites at North Halava to sites that were impacted by the discharge, as well as comparing our results to Quito's 2001 study. For an ecological study, this 2 years is relatively a short time frame. So longer monitoring would provide more evidence if in fact we're seeing seasonality trends, or if it's from the discharge or some other underlying factors. And then lastly, it's quite an effort to organize these surveys. So while having multiple surveys throughout the year, we really only had the capacity to do 1 per quarter. Further efforts are going to continue. This is done on a contract to contract basis, and it's still not determined how long they're going to be discharging the GAC. Talks maybe until 2027, potentially reducing the GAC discharge. If you're interested to hearing more about that, I have a QR code at the end of the slides to get more information on that. So conclusion and take-home messages. So when we compared our study to Michael Quito's 2001 study, we find that it was similar in the fact that we're seeing a lot of the same species. We're seeing flies, we're seeing caddisflies, we're seeing the rainbow guppy, the Chinese catfish, and the green swordtail. But now with our study, we're able to quantify, the populations out at these sites. And in addition, we're also seeing that Mexican mollies are present, and not only are they present, but they're actually the most dominant species that we're seeing. Second take-home message is that artificial increase in water flow to Halava Stream resulted in notable changes to the aquatic communities. More flow in an impaired stream brought larger abundances of benthic macroinvertebrates and fish. For Shannon Wiener diversity and the HSIBI, this really varied from site to site. And so that's likely that there's certain environmental factors that are impacting this, and it's unique to each one of the sites that we studied. The implications for ecosystem balance and management of non-native species or non-native fish is that, while we did see an increase in native fish, we saw an extremely large increase in the non-native fish. Where some species thrived, this might mean less biodiversity, and where there's less biodiversity, this might mean less resilient ecosystems. Are there any questions? If you're interested in finding out more about updated fuel spills estimates, there's a report here on the left-hand side. And then if you're interested to hear more about Navy's plans for shutting down Red Hill, that's on the right-hand side. You can also Google the Fuel Tank Advisory Committee meeting and the Red Hill 5 report.
Well, I have a question. I'm going to wait to our online question
We
first.
have an online question from Dr. Vaughn. This is such important work. Was water quality monitoring done as part of these studies? Any analysis of species collected for toxins? And why would abundance be higher in dry seasons?
Yeah, that was
Good questions.
Yeah, interesting. But we did see that was surprising, and not really in line with what I had thought, but we did see that.
Speak to.
Oh, yes, that's right. Hello. We did see higher increase in the dry seasons. There was a constant water flow, so maybe there was another environmental factor that was impacting them. As far as, sorry, what was the first question?
The third one or the first?
The water quality?
Water, oh, yes, right. So My project is specifically looking at the benthic macroinvertebrates in the fish, but the other things that we're looking at in the study is water quality. Yes, you know, there is some fluorescence testing being done, but then that's not. Furthermore, there's eDNA being tested. We're doing nutrient analysis and then also stream transect data. But yes, testing for toxins in the species would be an interesting study.
I have a question. Do we know enough historically about these streams to know what the natural flow would have been in these streams? Because obviously the hydrology of our streams has been changed quite a bit, you know, with development of the islands.
So you're asking,
Like, what was, I mean, you said Halava Stream is, you know, this
Mhm.
this stretch is intermittent, the South Halava Stream, hardly any flow at all. What would that have been like before all of this?
before all of this, even pre-contact, I mean, the whole Moku of Evo was just, you know, we had a water flow from Malka to Makai. You know, there was a lot of local IA in the surrounding areas. And there was groundwater available as well. So there's a lot of altercations or a lot of alterations that happened in the past 2 centuries for sure.
Yeah, okay.
Sorry if I missed this, but was there any pattern to when you detected the Oahu?
We can go back.
Dry
to the
season,
slide.
wet season?
So in the natural stream site, this was May of 2022 in the dry season. But we'd have to also further look at like the hydrological data to see, you know, there was probably flow at that time. NHUP, a lot of times when we went out there was just pockets of water and didn't actually flow all the way through. Only a couple times did it actually flow all the way through.
All right, thank you so much. Appreciate it.
And for those of you around still, just a reminder, we do have a Kamana afterwards. So if you didn't ask any of your questions of the students, stick around. There will be food and time to talk.
It's yours, yeah?
Yeah, 2 days.
Okay, let's, I think the way we're doing this is.
Yeah.
Zoom and share that. It's fine. Okay, we want to show screen too, I think. So. You should be able to. Go back and. There we go, okay. So take it away, Noah.
Aloha, my name is Noa Kamana, and the title of my capstone project is Improving Collaboration Between Native Hawaiians and Professionals to Explore Geothermal Potential in Hawaii. And I'd just like to thank the layout got messed up, but I'd like to thank my capstone panel members, Kumu Mehanavan, Dr. Travis Idle, and Nicole Lauzi, and my cohort and my participants for my project. So motivations for my project. First being climate change, especially the vulnerability that Hawaii has to the threats of climate change like sea level rise, but also our need to transition to green energy alternatives to help with climate change adaptation, but also to lessen our dependency on imports such as oil for our energy needs. And then also cultural motivation is around improving collaboration with Native Hawaiians and then utilizing indigenous knowledge to help lead climate change adaptation and sustainability in Hawaii. And then also for green energy projects in Hawaii to be culturally sensitive. So what is geothermal energy? In a nutshell, geothermal energy is the process is injecting water or another control fluid down into the ground to where we have geothermal heat resources. That liquid is then heated up, turns into steam, brought back up to the power plant to spin a turbine. Through that process, it cools down and returns to liquid state and is then re-injected into the ground to restart the process. This is how Puna Geothermal Venture works on Big Island. and it's a closed loop system. So some background into geothermal. Globally, geothermal is a growing industry with some players, including the United States, Thailand, Indonesia, and Aotearoa, or New Zealand. And then geothermal background in Hawaii, specifically. Geothermal research started in the 1970s and culminated with Puna Geothermal Venture becoming operational in 1993. And another major player in research and exploration here in Hawaii is the Hawaii Groundwater and Geothermal Resource Center here at UH Manoa. This picture on the right is from a project that they were a part of called the Play Fairway Project, where they mapped out all of Hawaii's geothermal resources across our entire island chain. Background into opposition to geothermal. In the 90s, opposition started with the Waukeleo Puna protests, which was protests against the drilling for geothermal, and also for the protection of Waukeleo Puna, which is a native lowland rainforest here in Hawaii. Also, a lot of opposition and protests stem from historical and continued distrust that Native Hawaiians have for our government, stemming from the overthrow of our monarchy, as well as distrust that local communities have for outside developers coming in and desecrating our resources and our aina. Some other notable protests here in Hawaii include the Kuku Wind Farm on the North Shore of Oahu, Nanakuli Solar Farm protests by DHHL residents on the west side of Oahu, and then also TMT on Hawaii Island, which is an example of opposition to continued desecration of sacred land and broken promises by our state government. So the cultural significance surrounding geothermal primarily is Tutu Pele, who is the Hawaiian akua for volcanoes and fires here in Hawaii. And Hawaiians attribute the creation of our islands to Tutu Pele. And we also, Hawaiians believe that lava, steam, lava rocks, other volcanic attributes here in Hawaii are the physical forms of Pele here in our islands. And the word Pele also translates to lava in the Hawaiian language. Traditionally, in Hawaiian culture, Pele and her elements are seen as kapu or sacred, and there are lots of kanawai and oli that speak to this. Some examples are the Kupaʻa kanawai, which states that any land that shows volcanic activity is the domain of Pele. And then jumping off of that, the Kaiokia kanawai speaks to what states that Kupaʻa kanawai, so any land that is active, is therefore sacred and kapu, so that no one should interact with that land until Pele has moved on or is not there anymore, not active. So for my project, my primary research question was how to improve collaboration between Native Hawaiians, policymakers, and industry professionals in relation to geothermal energy exploration in the Hawaiian Islands. And then my three objectives were to identify the primary hurdles facing geothermal, to identify the key cultural and community concerns and recommendations for geothermal, and then also to develop recommendations on how to improve collaboration. So my approach, I conducted interviews for my project. I pulled participants from three groups, one being Native Hawaiian community members, primarily from Hawaii Island, Native Hawaiian geothermal, people working in the geothermal field who are Native Hawaiian, and then non-Native individuals who work in the geothermal field. In total, I did 7 semi-structured interviews and then transcribed those interviews and conducted a thematical content analysis to identify themes across those interviews. So these figures just break down my participant pool and show that there was an even distribution when it came to gender, whether or not my participants were Native Hawaiian, and whether or not they worked within the industry of geothermal, and then also where each participant was from, primarily most of them being from Hawaii Island. So through my content analysis, I was able to identify 6 major themes. You don't have to read all these right now. They're going to come back up. So these 2 figures break down my 6 specific themes, and then how many times they were mentioned by the 3 specific groups, and then also how many group members from each group talked about those themes. The 2 yellow rows indicate the 2 themes that were talked about the most, which was theme 1, which was focused around sustainability and the need for renewables in Hawaii, and then theme 4, which is the cultural implications of geothermal. And then the orange blocks just show that those themes weren't talked about at all by that specific group. So Native Hawaiians, my Native Hawaiian community members didn't speak at all about themes 2 and 3, which was obstacles facing geothermal and then also support for geothermal. So getting into my themes, my first theme was the importance of renewable energy to help Hawaii become more sustainable. All of my participants spoke about this. They talked about that they understand the need for renewables and they want for Hawaii to become more sustainable. But participants differed in how they feel Hawaii should utilize different renewables. Other renewables mentioned were most popularly solar and wind, and then also hydrogen and nuclear. My second theme was the biggest obstacles facing geothermal. I found that the biggest obstacles aren't actually native opposition to geothermal, but number one being funding for geothermal research and exploration, and then also government support for research and exploration. In Hawaii, there's very strict regulations and permitting processes, which have deterred a lot of developers from wanting to come here and do geothermal work. And then also the need to fill the knowledge gap and correct misconceptions surrounding geothermal and its possible risks and harms that it poses to our communities and our environment. We need to distinguish what the real risks that it poses to those things are, and not see what the perceived risks are that people have. The third theme is reasons for support for geothermal. Some of my participants talked about looking at it as a gift from our Akua, something that we can utilize. Also, geothermal is a unique resource to Hawaii because it's very abundant here and it's going to be available for the foreseeable future. It also provides Hawaii with a firm energy resource, meaning that it's available 24/7, unlike solar and wind that's dependent on certain things. Geothermal also has the smallest footprint when it comes to renewable energy, both economically and ecologically. And a big thing that participants talked about was that it could be drilled for on every island. My fourth theme was the cultural implications surrounding geothermal. Number one being Pele and the traditional beliefs of where Pele is active, it's kapu and not touching those geothermal resources. But then also participants brought up the idea of, do we understand the whole picture when we drill into our Aina? Is there possibly unknown harms or risks or pollution that we're doing that are going to come to light 40, 50 years from now? And also, if compromise is needed, why is it always Native Hawaiians who are compromising our values and our ideals for development to move forward here in Hawaii? My fifth theme was rebuilding collaboration and trust, which has been lost. All of my participants agreed that there's been a lack of trust and a lack of inclusion when it comes to Native communities. And they also all agreed that collaboration is needed for any future development to be successful and to move forward. We talked about the inclusion of Native Hawaiians in decision-making processes, finding Native Hawaiians who are knowledgeable on the fields that are going to be affected by geothermal development and getting them into positions to make decisions. And then the acceptance of Indigenous and Hawaiian knowledge to help guide geothermal development in the future, being a part of nature and not apart from it, and making sure that geothermal development doesn't mess with natural flows here in Hawaii. My final theme was opportunities to improve social justice and benefits for communities who are affected by geothermal development. Puna has a very large Hawaiian population, much like other renewable projects like Kuku and Oahu's west side. So understanding the costs that those communities have to deal with when they have to host these developments, and then also trying to find how these communities can benefit from these projects and help offset those costs. One of my participants asked, what would happen if we built these projects in Hawaii Kai, a wind farm or a power plant? If it was proposed, would it even go through? So through my research, I tried to identify globally some examples of Indigenous people having positive relationships with geothermal energy. I found that Aotearoa and even British Columbia with the First Nations people have positive relationships. I'm going to focus on Aotearoa because of its similarities to Hawaii being an island nation, part of Polynesia, and their native people, the Maori, having similar origins, cosmologies, and history of colonization to Native Hawaiians. In Aotearoa, the Maori have a much different relationship with their geothermal resources than Native Hawaiians do. Their resources are much older. They don't have active volcanoes and eruptions going on. They also have a different history with their geothermal resources. Historically, they've utilized their resources for a wide variety of things, such as spiritual and cultural reasons, also cooking and healing properties that geothermal helps them with. Another difference that Maori have compared to Native Hawaiians is that their relationship with their Western colonizing government is different than what Hawaiians have here. They've been able to achieve a certain amount of self-determination and sovereignty within their own government. So that's provided them with avenues that are not open to Native Hawaiians currently. And a lot of their geothermal resources sit on Maori lands that are controlled by Maori land trusts. So their Maori have been able to be at the forefront of geothermal development, production, and management in Aotearoa. So some geothermal outlook here in Hawaii. The Resource Center here at UH Manoa is currently doing research and drilling in Lanai, looking at geothermal resources there. And then the state actually just approved PGV to ramp up to 46 megawatts, where they're currently at 38 megawatts. And then the Department of Hawaiian Homelands has expressed interest in exploring geothermal possibilities on their land to help benefit their communities. So through my research, I came up with 5 recommendations. First and foremost being the need to improve the quality of and increase dialogue and outreach with our local communities to improve collaboration with natives and locals alike. Second is to prioritize geothermal expansion outside of Puna. One, because Puna is relatively vulnerable to eruptions, as we saw in 2018, which damaged the plant, but also its vulnerability to weather events like hurricanes and things, so that if we put all our energy just into Puna and something was to happen, we would be out of luck when it came to energy. But also expansion outside of Puna provides us with the opportunity to try and work with our traditional kanawai and try to find land that Pele is no longer active, she's moved on, so try to work with that. Third, the protection of communities affected by development, whether that be financial benefits or things like jobs and management positions, trying to train skills instead of importing them to work the plants. My fourth is appointing the right decision makers, getting more Hawaiians into decision-making processes, but making sure those Hawaiians are, one, respected by the communities that they're going to be working with, but also they're knowledgeable in the fields that geothermal affects. So maybe looking for practitioners or people who study volcanism in the Native Hawaiian community. And then fifth, indigenous and community knowledge is expert knowledge. So acknowledging that, so that if geothermal is going to play a major role in Hawaii's green energy future, we need to prioritize and utilize the knowledge and voices of our Native communities. Thank you.
We have all the time in the world for questions. That's presentation. Thank you so much. Questions from the audience?
Oh, no, that was really interesting. I learned a lot. I'm from Hawaii Island and I didn't know so many things about Puna Geothermal Venture. Anyways, my question is, can you talk a little bit about how you recruited people for interviewing and any challenges or what that process was like?
Yeah, so for my recruitment, I mostly tried to look into organizations within like the energy field and ones that spoke about or worked with geothermal. So I looked at Puna Geothermal Venture, tried to find email addresses and things to reach out to people to try and recruit them to be a part of my project. And then from there, after identifying like a few people, I was able to just snowball effect, ask them to reach out to their contacts. And then I just built it from that. Yeah.
So you mentioned that there's, that regulation is one of the things that's keeping the outside folks from coming in. Do you know if any of those regulations have anything to do with community feedback over the years, or is it just good old fashioned state of Hawaii regulations?
From my interviews with some of the people who work within the geothermal field, I think it's mostly just state of Hawaii stuff. They said that one thing that they said was if people were to just say that they were doing groundwater research, that they'd be able to skip over a lot of the red tape. So just stating that you're doing geothermal brings up a lot more obstacles. Yeah.
Do you know much about the DHHL and what they're kind of thinking? Because they've got land everywhere.
Yeah.
Big Island and other places.
I haven't done like research into if they've had like hearings and stuff like that, but I know about it through my interviews, so people who work at PGV have said that they've had meetings and things with people at DHHL for them wanting to explore their energy options for their communities. Yeah.
Because that helped more of like a Maori type of a.
Yeah.
model where they're in charge of it and can.
Yeah,
Yeah.
how Hawaiians benefit from it. Yeah.
Questions online?
Noah, can you talk a little bit more about the treacherousness of benefits and how, it seems like a simple cost benefit analysis, but then often sometimes we benefit things like for more and more tourism, for example. But then that becomes a slippery slope where we're dependent on it. And just a little bit about that, maybe just relating to governance and governance capability and power in these situations.
Yeah. I think when it comes to finding ways for communities to benefit, yeah, it's not the idea of just paying off communities to be okay with harms and costs to our environment and to themselves. I think it's more trying to find that balance between making sure green energy and geothermal would be a positive thing for communities, but also not affect us in a negative way while, I don't know, communities could benefit, like you said, financially, but not have to deal with those harms or costs as well.
Well, I know years ago, because I've been in this field outside of work a little bit, there's been folks saying there's enough power, geothermal power on the Big Island for the entire state, plus some. But then you'd have to run cables or, power lines all through the islands, and that brings up its own set of issues with especially the marine mammal sanctuary for Hawaiian humpback whales.
Yeah.
And things like that. So it's, putting all your eggs in one basket, I think, is a important point to. It's interesting that all the islands potentially have geothermal capacity. I think would be a surprise to a lot of people.
Yep. I think right now they just said it's a matter of how deep you have to drill to get to that heat.
Interesting. Well, thanks so much, everyone. Thank you, Noah. But let's give a round of applause for all of our. This will be recorded, so we do have a recording of this, and so they'll be going forward. Thanks so much for our audience members for your attendance, your patience, your questions, your interest in this. I really appreciate it. And so thank you so much, and I believe we do have some refreshments.
GSO is hosting Kahana. I think it's in the courtyard. I don't think it's raining anymore.
Thank you to the GSO as well. They're always.
Please join us outside.
I gotta walk my dog. My dog's got a whole.
Thanks to all our folks online. Thank you so much for your attendance and your questions or all your other questions.
I love it. So long.